Ladies and gentlemen, esteemed researchers, scholars, practitioners, and industry experts, welcome to the second day of ICTer International Conference 2024, organized by the University of Colombo School of Computing. After a first day of keynotes and presentations, we are thrilled to continue exploring the forefront of technological advancements. So let's start with our research presentations.
Yes. In this session, we will hear from researchers presenting their innovative work. Each paper will be allocated 15 minutes for their presentation, followed by 5 minutes for questions and answers. Before we start, I would like to call upon all the research participants to join us on the table at the right. And yes, before we hand over the session, allow me to introduce the session chair. He is an expert in computer vision and he holds a BSc in Mathematics and Statistics from the University of Colombo, as well as an MSc and PhD in Computer Science from the University of Manchester. With over 100 publications and 40 years of teaching experience, he has held key roles, including head of the Department of Computer Science, as well as the Deputy Director of UCSC. Now as an emeritus professor, he serves as an Associate Dean in Computing at the Informatics Institute of Technology. Ladies and gentlemen, it is our pleasure to invite the session chair for the paper presentations, Professor N.D. Kodikara.
The session today, first paper is titled Transforming Software Size Estimation with Prompt Engineering, a ChatGPT-based framework for component-based systems. The authors of the paper are Tarindu Kumesh, S. Jayalal, T.K. Vijayasirivardhan. The presenting author is Tarindu Kumesh. Tarindu Kumesh currently works as a software engineer at Kodai's Tech, Washington, D.C., an experienced software developer with over 3 years of experience. He graduated with a BSc honors in Management and Information Technology. Tarindu's research interests include artificial intelligence, automation, and generative AI. So I invite Tarindu Kumesh to present his paper.
So good morning all. So my research topic is transforming software size estimation with prompt engineering, a ChatGPT based framework for component based systems. So this is the lineup of the presentation. So according to the reliable resources, low code and no code development has a future. Because of that, most of the companies has introduced their low code, no code development platforms. So low code development means drag and drop application components to create mobile and web applications. So component based systems software under the low code development category. So the problem is not only the component-based software, 50% of overall software are challenged and 90% of software are totally failed according to the Standish Group Chaos Report. So according to the literature, it is important to quantify software. So software development is a costly and somewhat unpredictable business. So it is very important to quantify software product, processes, resources to manage software development successfully. So the way we can software by time, effort, and cost. So cost is one of the important measurement because overestimation waste of limited resources and underestimation may exceed the budget. It will may underdevelop functionality and poor quality. So there are so many cost estimation factors like project size, team size, but the critical factor is project size. So there are so many size estimation measures, software lines of code, model-based estimation, function point, UML diagrams. So, but when we focus about component-based software, the measure we should use is component point, which is an extension of function point, it measures the size based on the number and the complexity of interfaces and interactions. So when we talk about AI tools, there are so many AI tools which are freely available to automate their people's day-to-day tasks. So when we talk about focus about ChatGPT, there are so many uh, uh, evidence that ChatGPT has used in those industries, including software engineering. So our research question was, can we use ChatGPT to automate component point calculation? And if so, how ChatGPT used for that? And what are the guidelines that we can recommend to develop such prompts to automate component point calculation? So our objectives would identify the feasibility to automate the component point calculation using ChatGPT, and then formulate and validate a framework for that. And finally, we are giving some guidelines to develop such prompts for automated component point calculation. So when we talk about the methodology, first we gather the data, then we extract the relevant data, and we follow an experimental task to develop an initial prompt, initial framework, which consists of a set of prompts. Then we validate the developed prompt, and finally we introduce a set of guidelines. So when we talk about the gathering data, so it is important to measure the size at the early stage of the software development life cycle, because most of the decision making tasks are happening at the early stage. So what we have at the early stage is requirements, project requirements. So, but the problem was, so the project data confidential for organization, we couldn't get any project details from companies. So what we did was we found some project data from previous literature. So the size was already calculated for all those projects. So we used that. So as I said, the component point calculation based on the size and the complexity of interfaces and interactions. So all the requirements are necessary for that component point calculation. So, and we have to optimize the input prompts because of the limitations of the ChatGPT. And according to the literature, accuracy will not increase by giving irrelevant data. So getting insight from the previous literature, we have developed an initial prompts. So then that initial prompt underwent a fine-tuning process through iterative experimentation. So based on the grammatical changes of to the prompts, we have categorized into three major phases. So in each phase, we had a major changes to the prompts. And finally, in each phase, we have applied those prompts into three selected projects. So in the first phase, what we did was we used only one single prompt. We just input the project details. Then we asked to calculate the size of the component based project. But ChatGPT didn't calculate the size. It generates some lengthy expressions, and it talk about the processes of component point calculation. And it asks some more information even we give that data. In the second phase, what we did was we start like a conversation with ChatGPT. So we carry out some step-by-step processes. Then we identified the importance of referring to previous calculation steps. So we found some keywords that we can use to make a linkage between steps. And we identified some component point specific word that should be start with block letters. And we use a project name as a reference name to the project. and it is important to use words instead of symbols. So but in the second phase also we didn't get any size estimation, but we got some positive improvements. It begins to refer to previous steps. And another observation was when a prompt containing more than one task, ChatGPT becomes confused. So what we did was in the third phase, we redesigned our prompts to perform only one single task in each prompt. And what we did was in the third phase, we defined some component point specific terms, and we make sure to delete if there is a history to prevent unintended reference to previous calculation process. So luckily in this phase, we got the size estimation. So because of that, we took those prompts as our initial framework. So when it comes to the validation, we use mean magnitude relative error. So it is important to go near zero in mean magnitude relative error. And we use percentage of prediction within a given deviation value. So it shows the capability to provide accurate prediction within a given deviation. So usually PRED 30 is used. So 70% or more than that will be acceptable model accuracy. So the way we can conclude the validity is, so we calculate the size of the project using the initial framework. Then we measure the mean magnitude relative error and PRED 30. So so the developed framework should get the mean magnitude relative error closer to zero, and should get the PRED 30 greater than 70% to say it as a valid. So lastly, we introduce a set of guidelines to automate the size estimation of component-based systems using ChatGPT. So when we talk about the results of the project, the research, first we introduce a guidelines to develop such prompts to calculate the size of the component-based system. So guidelines are, it is start a conversation with ChatGPT and perform step-by-step process, and perform one single atomic task in each prompt, and incorporate keywords to facilitate linkage between each steps. And it is important to delete the previous conversations, use plain English, and define some component point specific terms, and use some block letters for component point specific words, and use project name as a reference name. And it is important to avoid the formulas like this. So instead of that, we can use a descriptive ways, and we can use a descriptive ways to input table values like this. And we can provide examples when there are complex calculation are required. So as shown in this prompt. So another results was the framework we developed. The framework consists of 17 prompts. So each prompt in the framework perform only one single task. So it leverage the standard component point process. So we have specifically designed a prompt to input the project details into ChatGPT. So following these steps, we can calculate the size of the component-based systems. So when we talk about the validation, we evaluate the error of the suggested framework. So we use MMRE and PRED 30. So we got 27% mean magnitude relative error, and 75% of PRED 30, which is higher than the acceptable model accuracy. So what we can conclude is we have developed a framework to measure the size of the component-based systems using ChatGPT. The framework can calculate the size accurately. The framework has been validated using component-based projects. We have used reliable matrices to validate the accuracy. And finally, we have developed and introduced guidelines to develop prompts to automate the component point calculation. So when we talk about the limitations and future work, so we use GPT-3 model. So it has input character limitations. So because of that, we have to use small scale project because we can't use a large scale project. When the project becomes large, the data we should input will be large. So considering that limitation, we have to focus only the small scale project. And we have only validated the framework for component based systems and validated only for GPT-3. So as future works, we can see the accuracy can be increased by fine-tuning those prompts by increasing the acceptable model accuracy and reducing the error. And as I said, we use the project data from literature, not from the real world software project. So it is important to validate the framework using real world software project. So, so the framework's applicability for other development paradigm has not been checked in this research, and also other GPT models, and for the other AI tools like Bard AI. So this is the end of my presentation.
So thank you, Tarindu, for the presentation. Now the audience can ask questions.
So as I understand, you manually crafted your prompts, no? Here, ma'am.
Yeah.
You manually crafted the prompts
Yeah.
by looking at the 3 data sets you have.
Manually means we did some experimental stuff. There are
With
so
these
many.
3 data sets.
Yeah.
So that is overfitted, no? If you get a 4th data set, how you know that will work with your framework?
Sorry?
If you get another data set,
Yeah.
so how you validated with the same data set?
Yes.
You crafted the prompt with the same data set.
Yes.
So how you fine-tune them?
So for the fine tuning, we have to use more data. That's why I said in the future, as a future works, we have to use some good data, because we had the problem to get project data. That's why we use the data from literature.
I have another question. So, about the model hallucination. So, how can model hallucination impact the accuracy of software size estimation? Like you have mentioned the ChatGPT. So, especially in the component-based system, like what kind of strategies that you employ to manage hallucinations?
Sorry, I didn't get the question.
So the model hallucination is another aspect that we are looking at when we are training like GPT models. So in the model hallucination, so have you analyzed how model hallucination impact the accuracy of the software size estimation in this use case? And what are the strategies that you have think of? So
You talk about the validation?
No, hallucination, I think you know about model hallucination.
I'm sorry, I didn't get your question.
It's about we have to check the model. So in the model hallucination, what we have experienced is instead of getting the right answers, we can get some wrong answers.
Yeah.
So in that matter, I just have curious, have you checked that? But I think that's future step in research.
Yeah, we use matrix like pred30, it predicts the how much we can predict within the error given percentage of error. So we got 75%. There are errors, but it can predict around 75% of accurate predictions within that deviation, 30% of deviation. There are errors.
Okay, thank you very much, Tarendu. Thank you for keeping to the time. Okay, thank you very much.
Thank you so much.
Really appreciate it. The second paper is density-based query by committee, robust active learning approach for data streams. Authors are Ashoka Parabeshwara, O. Senavira, and G. Dharmaratna. The presenting author is Ashoka Parabeshwara. A BSc Honours graduate in Industrial Statistics from Department of Statistics, University of Colombo, achieving first class honours and receiving multiple academic awards, including CRN Bhargavi Rao Gold Medal for Statistics, the Gold Medal for Industrial Statistics, and the University of Colombo award at the Academic Excellence in Industrial Statistics at the 2022 convocation. He currently works as an analyst on the Data Technology Solutions team at Acuity Knowledge Partners. Ashoka's research interests include active learning and time series analysis, particularly for non-stationary data. He has also contributed to academic as a guest lecturer and by helping organize PyData Sri Lanka 2023 conference. I invite Ashoka Parabeshwara to present his presentation.
So, thank you for the introduction and good morning everyone. So I'm Ashoka Prabhashwar and I did my undergraduate research in the topic of active learning for data stream modeling, and this is like part of my thesis that I have submitted for my undergraduate. So let's start off with the introduction. So what is active learning? So active learning is like it focuses on training an accurate model with fewest labels as possible. So if you consider the image in the given figure, so there's a classification boundary, and that is the classification boundary that you have got for like training the entire data set. But if you take only the data points that is near to the classification boundary, those are the most informative data points. So using only those set of data points, you can easily still train the same model with the same accuracy. So that's the basic understanding of active learning. So in this case, so active learning it's widely used in modern machine learning problems because like now the data is very much abundant, and labels, it requires human expertise and it requires cost, like labeling cost, to get those labels done. So therefore active learning is very much like useful in such scenarios where data is abundant but the labels are not. So, and the other part of my research is evolving data, which is data streams. So with the IoT devices and all, like data streams are nowadays like very much popular, and there are some challenges which is inherent to evolving data, like concept drift, concept evolution, which is the changes that occur in the joint density or the joint distribution of the distribution. And also like data streams, they require real-time processing as well. So if you need labels to get done, it is very hard that you have to label set of like really large number of data points at a very small amount of time. So those are the challenges that is with evolving data. So this study mostly done with the like started with this the survey from this the recent survey, and it has focuses that there are algorithms which is like which are very accurate, but they are not on the on one hand they are not scalable, as well as on the other hand it's not like interpretable, because we have to have some interpretable model to verify the results that we get, like these are the informative points. So therefore, so we thought of using like looking into the literature, and in the batch data we have this uh, density based techniques which is not evolved like recently, it's only stopped with batch data. And so in our research what we aimed was, we just aimed to get this batch data scenario into streaming data, and it is blended with this like the final paper, which is active learning with evolving data, which is a comprehensive study on uncertainty sampling. So uncertainty sampling is the widely used technique in active learning, because it's like this. So let's like we have an incoming data point, and we ask a model to predict it. So if the model is like very much certain on it, if one probability is like zero 0.9 and the other is 0.1, then the model is very much certain. So we are not querying such things. We are only interested in like 0.55, like which is most uncertain data point. So this is a comprehensive study done on that, only on uncertainty sampling. So we have extended that, like getting the ideas from that study into our study, and developed three techniques to carry out active learning. So this is the density-based query by committee method for batch data. So the idea of this one is, if you take the data point A and data point B, so like data point A is the most uncertain data point because it lies on the classification boundary. But if you take data point B, it might be the required data point, because A is an outlying or the influential data point. So here, in like not only the uncertainty or the informativeness measure, here we are getting the representativeness measure as well. So to get the representativeness measure, we are using some similarity metrics, like how similar the existing data point with the rest of the available data points. But here in this batch data, the thing is, like we have the data set in our hand. But in the case of streaming data, we don't have it, like it's coming real time. So that's one challenge that we have to deal with streaming data. So we have changed, like we have done some alterations and changed that method into the like proposed for evolving data. So what we have done is, we have since we don't have the unlabeled data set, we get the labeled data set. But to compute this similarity measure, like as the time, like the streaming data it evolves, the label set keeps getting large. So therefore we have integrated the concept of moving window with a kind of variable size in the sense, like it's kind of a parameter that we can tune it, so that we will just compute the similarity measure based on that, like only the label, like the latest moving window of the label data set. And most importantly, like to make this technique more robust in the sense, like we can apply it to any of the data sets, because like if you use it similarity measures like popular similarity measures like Euclidean distance or Jaccard distance or like those things, it's only for quantitative or qualitative. But here we have used something like Gowers distance, which can be applied to both quantitative and qualitative, so that we can apply this method into any of the existing data sets. So here the variance. So we have the fixed. So what we do is, in this previous slide, so we compute this threshold, like this statistic, and if this, like we have a fixed threshold, then so we have three variants. So we have fixed. So we have three variants: fixed threshold, variable threshold, and the randomized variable threshold. So the fixed, it's kind of a fixed parameter that we need to find out. And if this statistics is greater than the threshold, we query the data point. But however, when it comes to this variable threshold and the randomized variable threshold, the threshold is set in a way that it will expand. So it has a parameter. So initially we set it to 0 or either 0 or 1, and then we have a like this increment value. So the increment value will change from like if the data is queried more, it will shrink the threshold and like it will reduce the amount of querying. But if it doesn't query the data point, it will expand the threshold and it will like increase, the increment value will come into play and it will expand the threshold so that more data points will be queried. So these are the like 3 strategies that we had developed in that. And in the experimental design, we have taken 6 widely used data sets in the streaming machine learning scenario, and we have categorized those data points into 3 status, where no drift, drift, and with drift. So we have used Advin drift detection method to detect like the frequency of drift, and the other one is the evaluation strategy. So to evaluate the performance of the active learning strategy, so we have used frequential evaluation, and also we have constructed this accuracy plot. So the purpose of this accuracy plot is we have compared it with the model with all the data points as well as a random model, because random model in the sense like if if we can just randomly pick data points from the stream and then train that model, and if it works perfectly well, then I mean like there's no point of using active learning. So to active learning to work perfectly, its performance should be better than the performance of this random model. So that's why we have compared the performances of active learning with random model as well as this model with all the data points. And moving on to the results, so the uncertainty sampling and the QBC are the widely used techniques in the literature, and they don't perform very well in the presence of concept drift. Like they work well only in the absence of concept drift. So if you take these 2 plots, which is the cover type data set that in my scenarios, so it's like it fails because the accuracies are less than the random model. So in such scenarios, like rather than using uncertainty sampling or QBC, it's worth using random sampling, because there's no computational cost involved. Just you can just pick those random data points from the stream. And this is the developed active learning strategy. So here we have the performance kind of getting better than the random model, and also like here we can see some observation which is visible in the literature as well. So here one of the active learning models performance is better than the model with all data as well. So this happens because sometimes when you take model with all the data points, there's possible overfitting or as well as some biasness is there. But here like we are just selecting only some required data points. So there's a like in the literature also it is stated the same. So there's the active learning can sometimes possibly work better than the the models with all the data points. So these are just the results from the methods, like for the with the drift and with serious drift. And like as for the future work, so I have used like a global outlier detection method, which is computing the distances, but instead we can use something like local outlier factor detection, and there's something called incremental local outlier factor detection we can use to like detect this like outlying, or the like it will give us a metric so to detect those outlying data points. So and also like I would as future work we can compare the computational times and the computational costs along with the accuracies, so that just to compare how it will work. So that ends my presentation. Thank you.
Thank you, Ashoka, for the presentation. Now the audience can ask questions.
I have a question. In your future works, you are telling using a local outlier factor detection technique instead of a global outlier detections. So, what are the limitations and advantages when you are using a local outlier factor design techniques?
I mean, the best advantage is the computational efficiency, because when you compute distances, like when the number of variables in the, like, let's say the predictor variables, like you have to calculate distances for each of the predictor variable, right? So once the data set becomes very large, like high dimensional data sets, so like this distance computation, that would be a kind of bottleneck. So rather than using that, we can use some like local outlier detection, which is like much more efficient than this global outlier factor detection. Hope I answered the question.
Any other questions? So let's thank Ashoka again. Thank you.
Thank you, sir.
Third paper is titled Utilizing Association Rules in Knowledge Graph for Enhanced News Summarization. The authors are Pilini Lakshika and H.A. Caldera. Pilini will be presenting the paper. Pilini Lakshika is a lecturer, probationary in computer science at the University of Colombo, School of Computing. She holds a special honors degree in computer science and technology from Uwe Wellassa University and is currently pursuing PhD in computing at the University of Colombo School of Computing. Her research explores innovative applications of natural language processing, machine learning, and data mining, particularly in developing knowledge graph-based abstractive text summarization and knowledge representation techniques. So I invite Pilini Lakshika to present us.
Thank you, sir. And good morning. I'm Lakshika, and here to present our research, which is utilizing association rules in knowledge graph for enhanced news summarization. And this is the outline of the presentation, and let's start with the introduction. So our research is specifically focused on the news domain, and there we are considering the news websites as the main news platform. And as you all aware about the challenges in the news summarization, you also might have experience in the headline brevity and the longer articles, and as well as multiple news articles on the same news event present different levels of information. So what is the solution? Solution is already addressed, which is computer-aided tools which can automatically generate summaries for the news articles. So if the solution is already addressed, why we are still talking about this? The reason is, since the 1950s, there are lots of plentiful solutions available in the research community and as well as in the industry. So following those conventional approaches, within the last decade, the knowledge-driven approaches have become a big trend, so including the sequential model, machine learning model, deep learning models, and the graph-based knowledge representation. Now, those are the techniques leading in the industry. So the reason for moving towards these technologies is the rich contextual representation and as well as the greater flexibility and the accuracy. So what motivated us to do a research on this? So we were greatly motivated with the techniques in the knowledge discovery and as well as with the enhancements of the machine learning algorithms. So we can initiate our research motivation as we were motivated to have a rich knowledge representation for the event-specific news information and as well as apply the techniques in the knowledge discovery to identify or the extract meaningful information from the knowledge representation. So our literature review spans across several areas. So started with the traditional approaches, we were moved to the machine learning based approaches, and later within the last decades almost all the studies are based on the graph based representation. So it started with the knowledge base, which is a very primitive representation of the knowledge, and then later with the invention of the Google Knowledge Graph in the 2012, there's a great trends of moving towards the knowledge graph based representation. So now we are having very general large scale knowledge graphs, including the DBpedia, Wikipedia, NEL, Yago, so on, and also domain specific knowledge graph specifically for the news information. So we further literature reviewed about the knowledge graphs because it can possess the logic of the human reasoning. That's why it has become a recent trend. And when it comes to the knowledge graphs, we can incorporate the background information as well as some domain-specific information, and they greatly support for the contextual analyzing and as well as semantic search, different kinds of integrations, visualizations, and so on. So if the solution is already available, why again we are working on the knowledge graph? The reason is, when it comes to the news articles, there's a great issue with the existing large-scale knowledge graphs because they cannot be easily extend or compact for a particular event-related news articles. So when there is a knowledge graph representation, there should be a mechanism to identify or extract the meaningful information. So that's the place where we are talking about the ranking algorithms. And almost all the leading researchers in the last decade, they are using a kind of traditional ranking algorithm mainly focused on the degree centrality measure. What is the issue? The issue is those traditional approaches doesn't consider the semantic relationship or the meaning of the information presented in the knowledge graph. So here we have listed some algorithms used in the leading state-of-art models. Here, as you can see, I have highlighted in here the components they have used in their ranking algorithm always depend on the traditional approach, which consider the degree centrality or the edge weight or in and outgoing edge weight, so on. So we thought, why we cannot incorporate the techniques in the knowledge discovery to extract meaningful information from the knowledge graph representation. So based on that, we expanded our literature review for the knowledge discovery techniques and rule mining, clustering, classification. There are several techniques that we can apply for the text documents. The main goal is to identify significant features, patterns, associations, or the dependencies, relationships between the textual data. So with that, we noted that the techniques in the rule mining, specifically having a proven results for the news domain, which use the a priori, FP growth, ECLAT-like algorithms to mine rules and using that rules to identify the meaningful patterns or the relationships in the news articles. So these are some models which used association rule mining to identify meaningful information or the associations between the textual data, more specifically in the news articles. So there, as you can see, most of the algorithms are based on, most of the models are based on a priori, either FP growth or different refinements done to the a priori algorithm and so on. So there was a problem for us to identify which algorithm performed best with the news articles. So we conducted an experimental study which indicated by the reference 29. So there we used news article data sets and we evaluated and experimentally proved that the FP growth algorithm performed best with the news articles. So with that, here we are stating our research question. So our main question is how we can improve the accuracy in the knowledge graph ranking algorithm to generate meaningful abstractive summaries. So with that, our research question is twofold. In the first question, we are trying to find how we can incorporate the knowledge taken from the knowledge discovery to our ranking algorithm. And in the second question, we are thinking about how we can incorporate the syntactic structure in the sentences of the news articles to this ranking algorithm. So this is just a theoretical concept behind the knowledge graph. Here the circles represent the nodes and the connected lines between these circles are the edges. So when we need to represent a text document, maybe a news article, to a knowledge graph, first we need to extract the meaningful information. For that we are using different modeling instruments. It can be either classes, entities, relationships, or moreover we can use the free text contents. So when we extract the information using these modeling instruments, there should be a mechanism to logically represent it using a knowledge graph. For that we are using the logical representation which based on the nodes and edges. So following the literature, we are using the triple, the concept of the triple to represent the knowledge in the knowledge graph. Triple is a combination of 3 individual components, which is subject, predicate, and object. Using these triples, we are representing the knowledge graph where the subject and the object are the nodes, the predicate or the verbs are the connected lines. And when it comes to the FP growth algorithm, following the relevant text pre-processing, we generate the transaction, then the FP growth tree, and we are identifying the frequent patterns. Using the different combination of the frequent patterns, we are generating the association rules. So this is the methodology we used. Following the basic text pre-processing steps in the phase 2, 2 parallel phases happen. The phase 2, where we acquire the knowledge from the articles and generate the knowledge graph representation. And in the phase 3, we are generate the association rules using the FP growth algorithm. The output of the phase 3 is directly feeding into the phase 4, which is the ranking algorithm. And then the ranking algorithm will be applied on the knowledge graph to extract most domineering features from the knowledge graph to generate the abstractive summary in the phase 5. So ranking algorithm is our main contribution. So when designing ranking algorithms for the evaluations, we consider 3 components. To represent the state-of-art methods, we use the first component, which is the degree centrality, and the second component and the third components are designed by ourselves. In the second component, we consider the subject, predicate, object availability in the association rules to calculate a score. And next, the association rule-based statistics. For a particular association rule, several metric values can be calculated, including confidence, support, and lift. So we consider those 3 values to calculate an overall score for the triples in the knowledge graph. And this is the composition of the proposed ranking algorithm. Here the algorithm 0 represents the traditional approach, which based on the degree centrality, and the algorithm 1 to 6 are the different combinations of the 3 components. So those ranking algorithms will be applied on the knowledge graph to identify the top K features, and using these top K features, we are manipulating a parameter which is known as the compression rate, and then feeding directly those information into the language model, which is the NLG Python language model. We are generating the abstractive summary. So when it comes to the experiment, we use the benchmark data set provided by the Document Understanding Conference in the 2002, which is based on English news articles. And it consists of 120 event-related news articles, and this paper represents 3 out of those. And this is how we constructed, following the necessary steps in the text pre-processing. We extract the meaningful information and convert those into the triples, and later those triples will be used to generate the knowledge graph. And when it comes to the FP growth algorithm, every news article will be represented using a set of selected keywords based on the TF-IDF score. And after that, we are applying the FP growth algorithm, manipulating several hyperparameters in the algorithm. And this table 2 indicates the results we received for the 3 article sets we used. And this is one snapshot of the results. And there, every experiment in the table 2 is getting repeated with the 7 ranking algorithms in the table 1. When it comes to summary generation, I told you that we are manipulating a variable called compression rate. The reason is the document understanding data set, confidence data set provide 3 different abstracts, which is 50 word, 100 word, and the 200 word abstract. So accordingly, we also generated 50, 100, and 200 abstracts. And we used, for the evaluation, we are comparing our model generated abstract with the reference summary given by the benchmark data set. So here we are using the rough measure, rough 1, 2, and L, along with the recall precision and the F1 score. So this table indicates the results we received. For ease of understanding, this is the graphical representation. So in the test case 1, we generate the we generate the abstract with the 50 words, and when it comes to evaluations, as these images in the A, B, C represent that algorithm 6, which is the combination of all the 3 components, always performing best than the other algorithms. So based on that, we repeated another experiment using the algorithm 6. Here we generated 50, 100, and 200 word abstracts, and based on the results, you can see that the abstracts with the 100 words performing best with the rough 1 measure, and the abstract with the 50 words perform best with the rough 2 measure, and again the abstract with the 100 words perform best with the rough L measure. And we conduct another experiment to identify whether there is any effect of the number of keywords that we use for the FP growth algorithm. Here the number of keywords is a kind of hyperparameter used in the FP growth algorithm. So as indicated in this table, for the document collection 1, we used a keyword value lesser than the average, equal to average, and greater than the average number of words in a sentence representing each article collection. So the results indicate that always the 50-word summary perform best with the 17 keywords, and 100 and the 200-word summaries are performing best with the 20 keywords. So when it comes to discussion, based on the results we received, we can conclude that algorithm 6, which is the combination of all the 3 components, always performing best, and the next best ranking is for the algorithm 4, which is the combination of the novel components introduced in our research. So based on the test case 2, that we can state that when we are using the algorithm 6, which is the best performing one, with the compression rate of 100 words, the abstractive summary generation perform best. And based on the test case 3, we can state that when we are using number of keywords for the FP growth algorithm, which is equal to the average number of words in a sentence representing a particular news article collection, it perform best. So we have successfully achieved the research question 1 by incorporating the knowledge taken from the association rules into the ranking algorithm. And when it comes to the research question 2, we have successfully incorporated the subject, object, and the predicate availability of the sentences into the ranking algorithm to get the higher accuracy. And the algorithm 4, which is the combination of the 2 components introduced in our research, perform best. And when we further incorporate the traditional approach with our 2 components, the algorithm 6 comes up, and it is having the overall best performance with compared to the other algorithms we evaluated. So our contribution is this novel knowledge graph ranking algorithm, which perform best when compared with the state-of-art models. And when it comes to the works that we are still working on, we moved away from the document understanding dataset, and currently we are experimenting on the CNN Daily Mail and the New York Times corpus, and as well as we are manipulating more parameters for FP growth algorithm. Further, we are planning to expand our evaluations with the support of the domain experts to conduct the human evaluation. And the major limitation in this research is we are considering only about the news articles in the English language, and also we are not consider about the multimodal contents in the news articles. And the other thing is, when it comes to the future directions, we are thinking about generating the personalized abstractive summaries based on each user's requirements, and as well as expand the knowledge representation more with the event-specific news representation. And these are the references we used. And I would like to answer your questions, and also your comments and feedbacks are most warmly welcome. Thank you.
Thank you, Hilini, for the presentation. Now you can ask questions.
So I have one clarification, nowadays LLMs are like transformer-based models are work well with the text. So summarization is one of that aspect. If you summarize these data by giving some few short learning or something like that, Have you checked how it's generate with your result? Compare that one. Your ultimate goal is summarization.
Yes.
So in LLM, context is learned very well.
Yes.
So have you done anything with the large language model to incorporate something with your research?
Yes, sir. As I indicated in the beginning, this is still ongoing research, and the information we presented in this paper belongs to some of the middle stage of our research, and now we are at the end, and we have the problem is like this: we cannot use the existing knowledge graph for our purpose because they do not support the event-specific information. So because of that, we had to come up with our own knowledge graph representation. So at the beginning, we considered the basic knowledge graph representation, and this result is based on that. And currently, we have incorporated the word embedding and graph-based translation models, and also temporal information, and so many things into our knowledge graph representation. And now we have established a well and contextually rich semantic representation using a knowledge graph. So for our latter part of the research, we are using that knowledge graph, and the things we presented in this paper is based on the basic concept of the knowledge graph. So it cannot be compared successfully with the state-of-art methods because our contribution is a ranking algorithm. So when it comes to the ranking algorithm, most of the researchers do not present their internal components they have used in the ranking algorithm. So it's really difficult to compare our results based on the ranking algorithms. So that's why we took the final summary and evaluate the final summary generated using our ranking algorithms with the state-of-art models.
Yeah, I have one question. How does your model method handle misinformation and biases in news sources?
Could you please repeat it? I didn't hear the beginning.
How does your method handles misinformation and biases in news sources?
Are you talking about the misinformation?
Yeah, you were discussing about the news articles and related things. If it includes misinformations, how you...
Yes, the question is, the answer is like this. At the beginning, I told you that we are considering the news platform. So we believe that the trustworthiness and the accuracy of the contents presented in the news articles, because we are taking the news articles from some established news websites. So when we are referring to a news websites as the readers or the news consumers, we are having the trustworthiness that they are representing or they are publishing the accurate information because they have the liability for that. So in that case, our research does not consider about the fake information or the misleading information included in the news articles themselves.
According to your research, ranking algorithm plays a vital role. May I know which type of ranking algorithm that you have used? It is a deterministic or probabilistic?
So in our approach, we are designing ranking algorithms ourselves, and we just compare when it comes to the evaluation, we are comparing with the traditional approach, which represents the pure ranking algorithm based on the degree centrality. But when it comes to our research, all the two components has been designed ourselves, and we build the logic and we build the algorithm for the calculations. So what we are doing is, at the end, compare the combinations of different components. That means we are having 6 ranking algorithms. Our experiment is to identify which ranking algorithm perform best, and moreover, to compare it with the state-of-art models only, we are comparing the summary generated using the algorithm 0, which is the pure ranking algorithm.
So ranking based on what probability or what type? You are ranking based on what type, probability, or what is the base of your ranking?
The question is whether ranking is based on probability or what?
this is a throw code that we used. So here we are calculating the probability values. So as indicating the second component, we are checking the availability of the subject, predicate and object in the generated association rules, and based on that, if that particular subject, predicate, object combination is available in the association rules, we increase the count by 1. And when it comes to the association rule based statistics, we consider the confidence, support and the lift values by taking the average of that. If a particular triple presented with these association rules, then we take the average to calculate a score for the particular triple. That's the mechanism that we used.
Okay, thank you. Great.
Thank you for the questions. So thank you, Tilini, again for the presentation. Yeah.
Thank you, Professor Kodikara, and thank you to all the presenters for their remarkable contributions to this session. Yet again, I invite Professor Kodikara to present certificates of recognition to our dedicated presenters. Would the following researchers please come forward to receive their certificates? Tharindu Ananda. Ashoka Prabhashwara. Tilini Lakshika.
Thank you, sir. It is an honor to introduce our first keynote speaker. He is an accomplished technology executive with over 25 years of experience in leading technology organizations. Currently, the Chief Technology Officer at Cambio Group, he drives innovation and strategic initiatives. Previously, as CTO of Trustly, he enhanced scalability and time to market with a new target architecture. His leadership, including roles as Senior Vice President of Engineering, CIO, and Head of IT Operations, reflects his strong track record in industry certifications, as well as optimizing development and operational processes. Please join me in welcoming Ludwig Kolmodin as he shares his insights on AI in healthcare.
Thank you. Hello, everybody. I'm standing close to those. My name is Ludwig Kolmodin. I'm the CTO of Cambio. I'm going to talk a bit about AI in healthcare today. So hope you will like the subject. I think it's a fascinating subject, and I think this is the future. So, the fourth industrial revolution has made a huge impact on our industry. And I think it has started already, and today I will talk about what's actually happening today, and also a bit about what's happening in the future. But we'll start with a short introduction of Cambio. So Cambio is a Swedish company providing software and services for the healthcare and social care markets, mainly in Scandinavia and Sweden and the Nordics. We're a growing business. We were founded already in 1993 by 2 engineers in Sweden, and we have been growing since then, and we are now a really big company, leading company in the healthcare industry in Sweden, with more than 70% of the market in Sweden. So Our offices, of course, the majority of our offices are in Sweden because we're a Swedish company. But we also have offices in UK, in Denmark, and the biggest office actually is here in Colombo. Here's where we have more than 300 employees, and this is the main hub for our development. So software development takes place here in Colombo, and in total we're more than 1,000 employees. And our customers. So mainly we are based in Sweden, as I said, having 70% of the market there. But we also have customers in Denmark, in Åland, in UK, and also, of course, we are spread out. We have customers in New Zealand. Our ambitions is to become the biggest in the Nordics, but also continue to expand in Europe and the rest of the world. So today, I'm going to talk a bit about background in healthcare. I'll give you some examples of where we are today, and then the challenges with AI in healthcare, potentials as I see it, and next step and what might come in the future. So I will start with a bit of the background of healthcare. And I know it's different in different parts of the world. My experience and my presentations is mostly based on how it is in Europe, but I think there are a lot of similarities around the world. So, for hundreds of years we have had the same situation. When you get ill, the doctor comes to your house with medical skills, with a small bag of his tools, a generalist, that will support you. The benefit of that, of course, that if you were sick, if you were ill, you didn't have to go anywhere. You stayed at home and you provided, the services were provided to you. In line with the first industrial revolution, we started to build hospitals, putting all the medical skills in one place. The bad thing was, of course, that you had to bring yourself there even though you were injured or ill. But you got the possibility to meet experts, and you can get intensive care, and you get a more comprehensive health care. Now, healthcare is provided to you everywhere. With IoT and technologies like video calls, remote monitoring, you can actually get the care that you need in your home. So with the right remote monitoring tools, with the instruments in your home, you will be able to get treatment and you get the monitoring that you need at home. And this, when we enter the area of AI, so that's the next step of the evolution. So I will talk short about what's already in place today. And there's actually a lot of AI-supported things out there. So what we have today that's already in place. I will start with talking about triage assessment. Triaging is the priority of a patient. So when you enter the emergency room or when you are in an ambulance, you have setting priorities. So depending on your medical history, your injuries, and compare that with other patients, you get the priority. So sometimes if you have that experience, when you enter the emergency room, you have to wait for hours, because that's depending on the priorities. People that seems to be less injured than you might have a higher priority based on their medical conditions. So today, these kind of priorities are actually set by AI. Patient diagnosis and medical imaging is something that is already in place. AI is very good at imaging. I'm going to talk a bit about more about that later on. Personalized treatment and care recommendation is quite commonly used across Europe. When you get your diagnosis and then you need a treatment program, there are hundreds of ways to get the rehabilitation or treatment programs and so on. And to set up the right program, AI is used. Speech interaction. To recognize speeches and conversations between doctors and patients. This is something that is highly used and very effective. It's actually part of Cambio's offering today. Clinical documentation and coding, also often in combination with speech recognition. It's a huge product. That's also something that is a part of Cambio's offering today. Healthcare management, I think this is an area where we really can use AI. It's not that risky. It's a lot of planning, patient flow management, etc. And there are multiple cases where it's used there. Population health, AI is used today to do simulations and predictions. Drug discovery, also for simulations. And medical research and clinical trials. There you have quite interesting experiments that you can do. One thing that you can do is to collect the data on an individual, create a digital twin, let AI do the tests and experiments and predict the outcome on a digital view. So you don't have to risk yourself. And there are a lot of other technologies that you can combine with AI that's in place today, augmented and virtual reality tools. But I will give you some examples that's actually in place today. And most of these examples are taken from healthcare industry in Sweden, but I know that they are actually in place in many other areas in the world. So I'll start with this. This is a Swedish trial that were ongoing during 2023, where you had the breast cancer screening, and we had about 80,000 women taking part in this. And the trial was that you had AI and compared AI results with 2 double-reading radiologists, and it turned out that the AI found 20% more cancer cases than 2 double-reading radiologists. So it's very effective. What we also found in this trial was that if you could have the AI doing the work first, you offloaded the work for the humans and actually saved up to 40% of their time. So we're not planning to replace the radiologists, but to assist them. You can be more accurate and you can save a lot of the work. There is an additional test ongoing at the moment, including 100,000 women. And the research now is focused on to see how much of the cancer cases are missed and see if AI can improve that. That survey is ongoing, or trial is ongoing, and it's about to be completed in December this year. So I guess the outcome will be the same. AI is very superior. Documentation and coding is one big thing in the healthcare industry. And by using natural language processing in combination with AI, AI is able to extract clinical concept from a conversation between a doctor and a patient. And this is something that is in place today. It's part of Cambio's products. And AI turns out to be very accurate. And you know, when the doctor writes his notes, you have different languages, you have different dialects. It can be quite hard to translate that into clinical coding. But AI is very precise. So it saves a lot of time, and it becomes very accurate. And the products that are in place today, since they are based on AI, there is always risks. And in order to get these products approved, you cannot let the AI take the full responsibility. So in the conversation between a patient and a doctor, AI will pick out the clinical information, create the journal, and that is actually done and completed. But in order to be compliant, you need to have a doctor sign off, and then it can be used. So we're using AI, but we are not fully trusting it, so you need to have that sign off. Prevention of sepsis. Sepsis is blood poisoning, and this is something that is quite common that you get in intensive care departments. So here, this is another thing that has been developed, and the implementation of a tool that is actually used at Sankt Görans Hospital in Sweden, in Stockholm. It's used in parallel with other tools. So it picks up all the parameters from the measuring instruments at the department. You get the blood pressure, the oxygen level, your breathing, etc., and constantly evaluate the risk of getting blood poisoning. And collecting all these parameters, evolving the situation, and then it will come up with a score between 1 to 10. How likely is it that this patient develop blood poisoning during the next 3 hours? Score it between 1 to 10, and then you also have a confidence level of 1 to 10. So if you have a high risk of developing sepsis, and that the AI predict that this is, I'm pretty sure, and the score high. And the goal here is to detect any cases within 3 hours and to be able to act. You can also use AI to draw images and protect healthy organs when you have radiation therapy. So this is something that also has been tested. So when you have your cancer treatment with radiation, you don't want to have this radiation treatment on the wrong organs, because you want to only hit the damaged area. So by using AI to draw up the pictures in the images of the healthy organs, you can see exactly where the healthy organs are and the area that you need to treat. So by using that, you can get more precise. So this is something that is a test that is ongoing, and I just guess that AI will be superior to humans in this. And we also aim to save a lot of time. Fall injuries, a completely different area. And this is where AI is used, and you don't actually take much risk of using AI, because this is just an add-on. Fall injuries are actually quite a common thing in healthcare, especially at recovery units and units where you stay a long time. Patients that are sick tend to fall out of their beds, out walking, fall, and injure themselves. And an innovation project in Gothenburg in Sweden tested an AI tool to read the movements of patients and learn about when a patient starts to move in a certain way. Is that the first step before they fall out of the bed, sit up, or fall again? And this was a very successful project. It turned out the fall injuries during a year was decreased with 67%. So this experiment was conducted during 23, and during May 24, they actually decided that we'll implement this tool through the whole hospital region in Gothenburg in Sweden. So quite simple things that you can do with AI, but it really improves healthcare. Increased training is also an area. Here is a test that was ongoing to improve training, where we used AI in combination with smart glasses and virtual reality. And it's to put local anesthesia in the right place. So if you're going to put the needle into a nerve, a trained doctor will do that very accurate. But for a new doctor, you need assistance. And AI has been trained following skilled doctors how they do this, and then they can, with virtual augmented reality glasses, it can show you and guide you to make a more precise injection. So these were some examples of what's ongoing and things that are in place today. But there are a lot of challenges. So this is a report from Gartner, leading research and advisory company in the IT business. They think that AI is not super effective in certain cases. They think it's very effective in content generations, in conversations, but most of the healthcare use cases is in the area where they say it's medium to low. So we really need to have that in mind, that the AI technology is not really mature. So you need to be very selective for the use case. You need to understand when you need to verify results. You need to understand which use cases where AI just supports and improve. And an interesting thing here, the survey in England revealed that 1 out of 5 doctors, 20% in the NHS primary care in England, actually consult ChatGPT. You have no idea if they're getting the right results. And you have no idea which kind of questions they ask. And they don't know how ChatGPT has been trained. So there is a lot of risks here today. Looking at where we are today also, this is Sam Altman, the CEO of OpenAI, and this is how he thinks the AI will evolve. So we can see that we are just in the very beginning. So according to Sam, we are past level 1, chatbots. We're about to reach level 2. Then we have level 3 with agents, and level 4, which I think will be very interesting, where we believe that AI can be part of the invention process. You can get innovations from AI. And level 5, when you have a full organization set up with AI. And if you look at YouTube and look for virtual hospital, there are some experiments with AI bots setting up, giving them different roles. You have the receptionist, you have the doctor, you have the patients, and you can have this like a self-playing organization. And you're sending in patients with different disorders, and the doctors treat them and then come out with a diagnosis. And you can also see that they improve over time. So it will become more and more advanced. That was just an experiment I found on YouTube, but I thought it was interesting. But we are just in the beginning. And I believe this will develop really fast. According to Sam Altman, we just entered level 2. And when we enter level 2, level 3 will become quite easily accessible, and then it will accelerate. But have in mind, we're just on the beginning of this journey. So 5 big challenges with AI in healthcare. Data privacy is one thing, because you need a lot of data to work on, but you also need to keep the patient's data private. Don't let it go into other people's hands. Biases in data is also quite a concern. If you train an AI on just a subset of the population, you will get biased data, and some people might get an unfair treatment. Lack of transparency. You don't really know how the AI come up with the answers. Can you really trust it? What information is it based on? Regulation and governance. We have a very, very trivial regulation today. And if you look at the European AI Act, it mostly say that AI is dangerous and shouldn't be used for healthcare. it must be more detailed, and we must have something that follows the evolution of AI. Another big issue is the lack of understanding. As I mentioned earlier, one out of 5 doctors consult ChatGPT today. Do they really understand the tool? Do they understand how dangerous it could be? I heard examples where nurses are using ChatGPT to understand the doses or the selection of medicine because they don't know themselves. Are they sure they're getting the right answers? But I think there is a lot of areas where you can use AI. Having this in mind, I will talk about some of the potentials. So we know that the AI models are not 100% correct, right? And even worse, we know that they hallucinate. If you try to give ChatGPT a Sudoku, they might solve it, and then you can see this is wrong, and then you ask it again, did you get it right? No. They make up answers sometimes. And then you can ask them to correct them, and then you get it right. But you cannot fully trust it. But I think there's multiple use cases where you can use GPT. And some thoughts that I have, you can really use it as an assistant. And these are use cases in place. But according to a study already in 2016, physicians spend 51% of the time in electronic health records. And we know that AI can be much more effective and more accurate. And also another study from 2019 found out that nurses spent 33% of their workday on administrative documentation. So I think you should use AI, but you should verify. Just as we do in some of the products that we have in Cambio today, use it for decoding, creating the journal, have a doctor sign off after reading it through. And also, if we can offload doctors and nurses, we make their life easier. A study have shown that many of the physicians think that administrative task is sort of the main reason for burnouts. So it can really offload and help. And as a knowledge bank, when you meet a doctor, you meet one doctor. He might be an expert in one area or a generalist. But with AI, you can take all the knowledge in the world and have it one source. So it has been tested, the GPT-4 has been able to set the right diagnosis for cases such rare as 1 to 100,000. So you just give it the input and then can find the right diagnosis on that. And just imagine if you have a very rare disease, how long do you have to wait to get the right diagnosis? And there is a lot of people today with undiagnosed diseases, not able to get the right treatment. They don't know where to go. Here, we have a great knowledge bank. And I think that we need to optimize our healthcare. And I think this is an area, it's a growing area all over the world. We have an aging population just giving higher pressure on the healthcare system. And you need to wait a long time to meet the doctor. And when you met the doctor, turn out you need to meet another doctor, and then you have to wait again. And I also think that with the right kind of assistment, you can avoid a lot of errors and the wrong treatments causing or harming or even killing people every year. So do really think that AI can help address these problems. When healthcare is not available, it's estimated that about half of the human population, about 4 billion people, don't have the adequate healthcare that they need. For a lot of disabled people, it's hard to go and see a doctor. And in many parts of the world, the only doctor you get to see is a generalist. He might not have any idea of your disorder. However, in the most remote and the most poorest places, you always have a mobile phone. And you would be able to have access to an AI. And it might not solve all the problem. It will not give you any physical treatment. You will not have any relationship management. But it could fill a significant gap. You could get an idea what's wrong with you. You could know what kind of medicine you need. So it could fill a gap. So I think that there is a lot of things that you can do, but regulations and training is really necessary. You can use it where there's no other alternatives to assist, but do not trust the results. They do hallucinate. And I think it's very important that you have that in mind and verify the results. So, what's next? My prediction. I think prediction will be utilized more and more. Predict what's going to happen to you. And when you can predict, you can prevent. If you prevent, you can make people stay out of the healthcare system. And that will optimize the healthcare system. Precision medicine is something that I believe will come more and more also. Drugs tailored to fit you based on your input. And then one thing that I think will happen more and more also, it's the interaction between you and the doctor. If you have been to a doctor recently, you notice that you're sitting at the computer, writing and typing things. But if you can have an AI listening to your conversation, coming up with suggestions, you will actually be able to talk to the doctor, and the doctor doesn't have to talk to the screen. So that is what I believe the future will look like. And before we take any questions, I just want to say that AI is not only part of the products and the programs in the healthcare, it's everywhere, as we know. And at Cambio, we not only have the products with AI, we also use it within our software development. So here in Colombo, we have 300 developers using Copilot, Microsoft Copilot, Git Copilot, assisting them in the development. So we're using it for generating unit test cases. We're using it for suggestions when you code. We're using it to sort out bugs, finding dependencies. And we introduced this spring, and it turned out after about half a year of usage, we can see about a 10% improvement in efficiency. It takes some time to measure this. So we measure the throughput and we measure the quality, the number of bugs. I would say it's a bit too early to say it's a success, but all trends pointing in the right direction. So we do have AI also in development of AI-based products. So that was my thoughts about AI in healthcare. And now if you have any questions, I'm done.
Thank you, sir, for your inspiring talk. My name is Luther Becker. I will talk about open source later this day. And you stated the message that it's not just using AI, but verify results. And my question is, what is Cambio doing in the sense perhaps of open source to give the transparency for verifying exactly this in the products of Cambio?
Oh, that was a good question. The products that we have today is mostly speech recognition, and it's not based on open source. It's a partnership with Microsoft mainly. So I wouldn't say Microsoft is an open source company in that way. But what's important for Cambio is to create trust. So any products that we use, we need to make sure that we have a trustworthy partner. And when it comes to data, it's also something that is very sensitive. We need to prove that we secure data, and we must show what the data is coming from. And data is, especially in Europe, highly regulated. So you can never leave the patient data to a third party. You need to be in control of your own data. So yeah, I hope I answered your question to some extent at least. Thank you.
So you mentioned about chatbots. So can I know your thought on using AI chatbots in domains of mental health, like an AI therapist?
I think that using ChatGPT or AI bots as a device, as an advisor, it can be really helpful. But I think discussions that we have had is that you need to be in control of the data it has been trained on. And if you're going to use it just access it from the web, you cannot really trust the results. So you need to make sure that you train your own models. But again, the advices that you get from it cannot 100% be trusted. You need to verify it. Even though it probably in most cases are far better than a human, but you need to trust the results.
Maybe I come next. I don't know if you can hear me, but thank you very much. Very nice talk. You did not actually mention robots, so I was wondering a bit what you think about, do like robots have a place in healthcare? And if you're looking far ahead, will robots do some simple surgery at some point?
Robots are not really my area. I think that we will getting there, especially when it comes to surgery. We already have a lot of tools that offloading humans. You can actually do remote surgeries today where you're actually not sitting in the same room. Having robots taking over, I think that is coming, because the robots and AI-based robots in the future will be far more accurate than humans. We're not there yet, but I believe it's coming. For Cambio, we're not looking into physical machines like that. We're more into the software part, but it's a connected area, and I believe we will rapidly move into something new. Thank you.
Yeah, so I'm agreeing that about that thing that you told about data hallucination. So really, it's actually true that 50% of the time that I also see the data hallucination part. So what if, like, where are we? Like, let's say now there is a chatbot where they could say exactly, okay, this particular, based on this particular book, that they could extract some sort of information, and they have all the patient cases where, let's say for an example, the patient has a weight less than 40 kilograms, and they could live with a very lower heart rate at least one day. So there are special cases like that. So what if the AI, the chatbot could say the logical reasoning, like most of the time that I see the probability, but what if the logical understanding, where are we, like in this research, where are we, like when can we go to that phase? Like in your cases, were you able to like have that, like show the logical reasonings behind this decision making? Like I know that explainable AI is there, but it still shows it still identified the highest probability for this particular decision in the model. So, but the interpretability of where and why we took this answer is like, where are we in this reason?
Okay, that was a long question. I will try to.
Yes. Yeah, I would like to know about that, the wrong thing about that question too.
So just thinking about how you can train them and what data they are based on, you can give a lot of input to an AI model, asking them for the result. What you can do, you can actually have AI verifying itself, which I think is a good thing, and you can also ask them to give an answer to how they are based, which information they base their information on. So there are multiple ways to verify the result. I think you should always verify results with another human that has some knowledge about the subject. But letting AI verify itself, you can ask them which document are the information based on. Is there research papers that can sort of back up your arguments? And you can also ask them for related articles that shows the same results as them. So I think you can use AI to support you in verifying the results. Yeah, I don't know if I answered your question, but that's an answer at least. Thank you.
Yeah. So actually, so first of all, I would like to thank you nice set of words that you have actually told about the AI in health. Yeah. So my question is as a certified engineer and as well as the co-founder startup, we are also doing the healthcare products as well. So two couple of general questions. So the first question is, when I am before couple of months ago, the Oxford University, so they have found out there's a research study that able to detect heart disease, heart attack characteristic before 10 years ago. So that was a groundbreaking research. So in Europe, what do you think about this kind of attack prevention, attack prediction? So according to your knowledge and your industrial expertise, so how do you think Europe actually how well ahead of the race of this prediction cancers and diseases? So that was my first question. And the second question is, so what do you think about the data security of the patient data? Because one of the critical data, if we see in the overall industry, the first one is the financial data and the health data. So those two are very critical data. So even the pharmaceutical has special laws to protect the data. So what do you think, you have mentioned the European AI the Act as well. So what do you think, how likely to be the companies, healthcare companies, protect this data and work on well? So that's my second question.
Treat data, and it's you need data in order to train a any connection to the real patient. And that is something that we work with a lot in Cambio. We need a lot of data to test our products, and you need to make sure you have proper data, and you need to have synthetic test data. So it is a challenge, but you need to find your way around that. And then as a patient, you also need to, of course, provide your data if you're going to get the right treatment. But it's a big challenge for the whole business. If data was free, it would be much more easy, right? When it comes to different research and finding, you mentioned something about heart attacks. In general, I think we are in the early stage of all this kind of research. We find amazing results, and you can see that AI can support you in many ways, and it's often very superior to what you can do as a human being. And I think we are just in the early stages. We will have this more and more introduced into our products, and it will offload the physicians and the healthcare system. But I think we need to wait just a few years where we really have this fully automatically implemented, because we do use it today, but we don't trust it. And I think we are actually doing the right thing. I think we should embrace the new technologies, but we are not mature enough. So if we don't continue to monitor this, we might sort of derail. and people will die. So we need to mature. In a few years, I think when the technologies have been more matured, we have better regulation, it will be fully implemented. Thank you. So unless there are no more questions, I would like to say thank you very much.
Thank you, Ludwig, for that enlightening session on AI in healthcare. To present this talk, we have a small token of appreciation prepared for you. To present this token, I would like to invite Professor Kapila Dias to join us on stage. Thank you once again for your valuable contribution.
Thank you.
So let us take a 30-minute break for refreshments, which you can find to the right. And during this tea break, feel free to go through the poster presentations in the back of the hall, and we will resume the next session at 10:40 a.m. Now proceed with the next round of research presentations. As in the previous session, each presenter will be allocated 15 minutes for their presentation, followed by a 5-minute question and answer session. I kindly request all researchers for the session to join us at the front table to the right. It is an honor to introduce the chair for this session, a distinguished scholar and esteemed educator, Professor K.P. Hevagamage. Professor K.P. Hevagamage serves as a senior professor in computer science at the University of Colombo School of Computing and is a former director of UCSC. With a profound expertise in human-computer interaction, software engineering, e-learning, and ICT for education and development, he has made remarkable contributions to the field. Holding a BSc in computer science from the University of Colombo and a Doctor of Engineering degree from Hiroshima University, Professor Hevagamage has published over 180 research papers and received numerous awards for his contributions. As a senior member of IEEE and ACM, he has led the Information Systems Engineering Department of UCSC, coordinated the UCSC e-learning center, and directed the CEDA-funded National e-learning project. His commitment to academic excellence also extends to supporting quality assurance in higher education, both locally and internationally. Ladies and gentlemen, it is my privilege to welcome Professor K.P. Hevagamage as the chair for our next session of research presentations.
Okay, shall we start? No, okay, good morning to all of you. Shall we start the session? We have two papers. The first one is detecting cryptographic hash functions through electromagnetic side channel analysis. Three authors, Mr. Gayan Akmimana, Darshana Kasturi Ratna, Asanka Sayakar. And presenting author is Mr. Gayan Akmimana, is a graduate from the Faculty of Science, University of Colombo. He has completed MSc in Information Technology and Cybersecurity in 2024 at SLIIT, currently working as a software engineer at eGravity Solution Private Limited. So, Mr. Akmimana, yes, you can take. You have 15 minutes.
Okay, good morning. So I am Gayan Nakmimana. Our research is detecting cryptographic hash functions through electromagnetic side channel analysis. So first of all, let me introduce what is side channel attacks. So basically the idea behind a side channel attacks is that a physical characteristics of a system can leak information about its operation. So for example, you can see if we take a encryption decryption system, so if we input key with the plain text, so when we convert it to a ciphertext, so we can leak or we can extract some information with the heat, time, power or the electromagnetic analysis. So in this research, with these classes of side channel attacks, we consider about the electromagnetic radiation analysis attacks. So when we went through the literature review, so we found two major papers. So in this paper, they analyze these hash algorithms through Node-MCU platform. So again, in this research, they used HackerF software-defined radio to capture EM radiation in a Raspberry Pi. So we use these two papers and a lot of literature to this research. So in this research, we choose Node-MCU as the device under test. So in the Node-MCU, it has ESP8266 IC. Some Node-MCUs, they have ESP32 IC. So because we choose this platform because most of the IoT devices, they use Node-MCU or this chip as the base microcontroller for their developments. So then HackRF is the device we use to capture the electromagnetic radiation, and HackRF, it's a device we can transmit or receive 1 megahertz to 6 gigahertz frequency signals. So therefore we use this device to measure the electromagnetic radiation. So this is our methodology. So first of all, we try to find where is the best place to detect EM radiation in the Node-MCU. Then we develop custom firmwares. So then we divided our data into three categories. So one is we choose MD5 hash algorithm, then we choose SHA-1 hash algorithm. So then the third one, the third data set is other than these two algorithms. So then we develop the classifier and then we evaluate and test the data. So this is the experimental setup. So we used Node-MCU as our device under test. Then we use a computer to upload the firmware to the Node-MCU. Then we use a HackRF device to measure the electromagnetic radiation. So these are the tools we use. We use a couple of software-defined radio softwares. So GQRX, Cubic SDR, and SRD Angle, and the GNU Radio Companion. So these are the softwares we use during the experiment. So when we went through the data sheets and the literature, so we found there are two main frequencies that we can get the information. One is 52 megahertz and the 80 megahertz. So then we try to get the leak information, and we satisfy the 52 megahertz and the 80 megahertz. These are the screenshots that we try to identify what is the frequency that we can get the information. So finally, here you can see in the 80 megahertz we have kind of leak information. So then finally we found this is the place where we want to place the H-loop antenna to get the information from the node MCU. Then we divided our data set into two categories, so 52 megahertz and the 80 megahertz, then the MD5 hash and the SHA-1 other than the MD5 and SHA-1. These are the data sets we collected. Then how we collect the data, so we use the GNU Radio Companion tool. So in that tool we can create some blocks, Python blocks, and we can collect the data. And all the filters, those things are included in the tool itself. So this is how it looks like when we collect the data. So these are some screenshots. So this is the power spectral density of the signals that we extracted from the node MCU. Then when we analyze the data, these are the center frequencies that we took the information, and we have EM trace files, 720 EM trace files we analyze for this experiment. So then we train, we got already trained model. Then these are some kind of results that we got. Then finally, these are the accuracy that our trained model. MD5 we have 0.8, and the SHA-1 we have 0.9 accuracy. In the future, we are trying to expand this one up to more, explore other hash algorithms, and try to involve CNN for this experiment and try to optimize this model for the edge devices. So thank you very much for the attention.
Thank you very much for the presentation. I would like to see whether we have any question from the audience.
Your problem is a classification problem, no?
Classification, sir, first we want to identify, the basic idea is identify a hash. Is it a hash algorithm in the node MCU or something like that, the problem?
Yeah. So now you run on a specific device.
Yes.
But this radiation depends on the device you run the hash algorithm.
Yes.
So how you generalize this one? If you run in another processor, you will get a different pattern.
Yes, maybe, sir. So yeah. we took information in a specific device. So we try to expand it in another experiment. So maybe sometimes if we take one node MCU to another node MCU may be different. But we try to, in the next step, we try to expand this experiment into that kind of level.
Other thing is, you have how you prepare the data set. Can you explain? It's like a time series data, no?
Yes, sir.
So how you, for your experiment, for your KRAS, what is the model you train?
So it's a KRAS sequential model I took for this experiment.
So
it's a LSMT.
What is the time duration you capture for the signals? Then can you explain that one? How you?
One signal I capture up to 10 seconds. So then I slice it to a separate windows. Then we feed into the model.
How many data? What is the size of the data set? For a particular you have three cases.
We have three cases.
Two hash algorithm. One is normal run, no?
So
for each one, how many data points you get?
So HacRF, it's the bandwidth 20 megahertz signal. So then we have 3 categories, then 8 data sets for EM traces for each category. So if I take 10 seconds, so it has a kind of 20 megahertz signal. So it has kind of a lot of data. I didn't measure the size of those data. I slice those into some windows and I feed to the model.
Any other question? Yes, sure.
Thank you very much. Very nice talk. I was wondering, how close do you have to be with your antenna so that you can get the signals that you want to order, then to order to be able to classify?
Sorry, sir. Can you repeat it again?
How close do you have to be in order to be able to do your work? How close does the antenna have to be to the MCU?
Antenna should be very close to the device, sir. Otherwise we can't get the good signal from the device.
Thanks.
Looks like no other question from the audience, but I would also like to ask one thing from your presentation. So it's clear that your experimentation you did in a analysis using the CNN model, and what was the final conclusion that you can make it based on this one? Because it was not very clear. You showed your results, but from your point of view, what was the conclusion that you can give it?
Something we can say is now when we detect hash algorithms in a this kind of edge devices. So for example, let's take, so if we develop some devices, so maybe sometimes our devices may be victim of a kind of botnet, so that kind of scenario. So if we can identify, for example, let's take now we know our firmware does not contain this much of hash calculations, but sometimes we can say our device has sometimes very low, very slow, or some kind of scenario. So if we can detect are there any more hash algorithm calculations, then we can say without log into the device, so that kind of scenario, so we can say maybe we can predict so our devices may be a victim of that kind of botnet or any other scenario. That is one example in this research.
Okay. If there is no other questions, we can finish this presentation. Thank you very much.
Thank you very much.
So we will go to the next presentation. It's titled as an unsupervised discovery of salient design features of the websites. Authors are T.T. Kaluarachchi, DMS Disanayaka, M.I. Vikramasinghe. The presenting author is Disanayaka is passionate about the machine learning research with the focus on the unsupervised learning techniques such as clustering and anomaly detection in collaboration with the UCSC. He's a senior software engineer at WSO2 and enjoys traveling, discovering new music, engaging in thoughtful conversation that broaden his perspective on various topics. Yes. So may the desire, okay.
Good morning, everyone. So I'm going to present our research, which is unsupervised discovery of salient design features of websites. Okay, imagine for a moment, there are around 3 billion websites around in the internet currently we have. and in daily the new websites around 200,000 websites are coming into the internet. So, and that websites can be a personal blog or a company's landing page or a complex website or any other government site or any other thing. So, when we take a website, it is a kind of a first impression for a person or a company in online space. And because of that, businesses pays a lot of amount money to keep their online presence and keep their brand reputation in the online. So when you take the web development process, it takes several stages. We need to plan, design, development, and launch the website, and we need to maintain that. So because of that, it takes a lot of money and lot of effort for that. And when we come to the current technologies and models, we know that there are software as a service. We are calling it SaaS, and the SaaS has transformed the existing businesses to making users available their services easily and effective way with online. And our aim is to provide similar kind of thing to in order to automate the creation of the websites, focusing on automating the design process of the websites. And our goal is to reduce the cost and the time which takes to design the websites. And with that goal in our mind, we isolated one research problem, the main one, which is it possible to categorize existing websites in the internet based on their visual appearance? So that's the problem we are addressing with this research. And to cater that, we isolated research questions based on that. And one thing is we need to identify we need to classify existing websites based on their design. And the other thing is we need to identify what are the core features which involve to identify a particular design, uniquely identify a website design. And other thing is we need to know how those core features affect for the overall design and for the classification. So our objective is utilizing machine learning techniques to classify the websites and in order to automate the design process. So for that, we are using clustering techniques, and especially here we used some self-organizing maps for the clustering purposes, and I will explain why and how we are using that in the later slides. And to stay focused, we have defined our scope. So in our scope, we are trying to identify the design features of the existing websites, and we are mainly focusing on website layouts for that. And you know that in a website there are a lot of elements and components. So we are not covering all of them. We are covering the basic structure of the website in this research. And when we talk about the related works, there are a couple of related works we have found, and some of them are generating websites based on the components, mockups we provide, and some of them are generating prototypes for mobile views and those kind of studies there are. And some of the studies, the history of the web design, we covered them also. And out there are some products related to this, and you can see in the screen redraw, Vismode, sketch to code. So those with those tools, we can generate basic templates of a website by providing mockup or by typing what we need, that kind of thing. Okay, let's come to the research design. So this is how we have planned. We have the websites in the internet, and we take, since we are using the appearance based clusterization, we take the screenshots of those existing websites, their first landing page, and we collect them, and we apply the image processing techniques to process images, and then we prepare our data set. Then we separated the data set into training and testing data, and we use some, we create some self-organizing map for that model, and we apply the testing data, and we generate the reports. According to that, we analyze and come to evaluations. So here's we have prepared. Here's how we have prepared the data. So you can see in the left side there are represents the website screenshots, and the screenshot is an image, and it contains pixel values. So we place those pixel values in one row for one image, and likewise we prepared our data set. So, and I mentioned earlier, we are using self-organizing maps for this clusterization. The main reason is since this involves in higher dimensional data, we need to reduce it to a lower dimensional space. So SOM is best algorithm for that, and SOM is inspired by how our brain works. You know that in our brain there are separate areas which is specified for special functionalities of our body. So similar to that, self-organizing map, it's in the right hand side you can see that is called a U matrix, and similar to how our brain separated the separate phases, clusters, when we feed the data into the SOM, it output the clusters similar to how our brain works. So this is also a similar diagram, and in the left hand side it shows represent the input images, and the right side there's a row matrix, and this shows how an input identifies a best matching unit from that matrix in the map. So the right hand side, each node calls the neurons, and what happens is it takes the Euclidean distances of each of the neurons for a particular input, and identifies the lowest distance item and takes as a best matching unit. So that's how in processing happening. And I need to mention how we collected the data. So we took Alexa's top ranked website list, and we ran a web scraping script and opened those websites and took screenshots. And we had to manual enrollment also because there are some websites which are down, and some websites are not permission denied or something like that. And so for that we need to manual check and remove them. And other than that, there are some network failures and browser not supported kind of things. So for them we need to re-scrape and collect the data. And yeah, as I mentioned earlier, we had to remove these kind of website from that list. And yeah, let's come to the best part, the experiments. We have done the experiment in 3 stages. In the first stage, we manually created layout kind of diagrams and tried it with the SOM, whether it clusters well or not. So then we, in the second phase, we ran the same thing using the actual websites, taking 100 of the websites, and then after trying out that we did the same experiment for 1,000 websites. In the first phase, we have I told that we manually created wireframe-like wireframe-like images for the training, and we have tested how the image processing techniques can be applied in order to get a proper clusterization. So we have used these image processing techniques. I will explain. So this is the in the first phase how we have manually created wireframe-like diagrams. So these are all the images, and this is the training data, and this is the testing data. And here in the right hand side you can see the result of that. So this is the U matrix, and in the dark areas they are the clusters, and light areas it shows the boundaries. And here the shaded version of that same matrix, and this is the 3D version of that. We can easily analyze by each of these different type of diagrams. So in this diagram the value shows the clusters, and the peak shows the boundaries of those clusters. And then after taking that U matrix, we checked whether that clusterization happened well or not. For that we check the best matching unit of each of the input data set we provided. And you can see the items are placed in the middle of the clusters, which means the clustering thing happened as expected. And we need to apart from that, we need to ensure that the topology also preserved as we are expecting. So for that we have to check the first, second and third BMUs also. So as you can see, we got the same first, second and third BMUs in the same cluster. So we know that the topology also preserved with this. And as to analyze easier, I placed preview images of those wireframe-like graph we have trained, and you can see that in the middle side there are it clustered website with less complex, I mean with one vertical line kind of things, and the in right down side you can see the more complex layouts are clustered into that area. Likewise, we got better clustering with this, and this is the testing data we have feed, and this is also clustered as we are expecting. And then we have tested how the initialization of the U matrix affect for the clustering. So we have done different kind of initialization methods, and we saw that rather than the random initialization, other incremental and 0-1 initialization methods provide the better clusterization. So we go ahead with that. And this is just showing how the incremental initialization method initialize the values in the U matrix. And then we have done the experiment using image processing techniques in order to get more clear classification. So we have dilated the lines, and for that we got a better classification than without dilating the image. And then we added the smoothing filter, and for that also we got a similar kind of better one without the dilation one. And then we know that we have applied some image processing techniques, and from that we got better clusterization. Then we applied in the second phase we applied top 100 images of the websites, and applying that, since we have in the first phase we have drawn the lines and did the clusterization. So from these images we need to get fetch the layout from those images. So before that, first what we have done is we grayscaled the images and did the experiment, and for that we got this result. And as you can see, the grayscale images are clustered like this. You can clearly see in the top down side there are light themed images are clustered in there, less complex ones, and top left side the dark themed websites are clustered, and top bottom side there are both of the dark and white areas websites are clustered in there. We can analyze likewise see the clusterization of each areas. And then we added the edge detection techniques for the grayscale image, and that's the right side is the output of that, and this is the result of that. So this is not showing actually the layout lines. However, we in the first step we did the experiment on top of that. Then we added more image processing algorithms like gradient magnitude, gradient direction applied for this the same one, and it shows the better layout structure than the previous one, and we got the results also similar to the better one than previous one. And then we did the experiment more to isolate the layout structure, extract the layout structure from the images, and we added some fetching horizontal and vertical lines and merging them, and in the top down side you can see the vertical and horizontal lines are there, and noises are reduced. So we did the experiment for that also, and we got a better result than the previous experiments. And so far we have done the experiment for 100 websites. Then we know that what are the image processing we applied and how they affect for the outcome. So then we did the experiment for 1,000 websites. We added those I mentioned image processing techniques, and you can see the each stage of the image processing applied for the images screenshots. And when you come to the result and evaluation, this is the result of the U matrix, which is trained with thousands of websites, real websites. And we have generated the wireframes of those websites on top of the U matrix. It's not clear because there are thousands of images placed here. And to analyze easier, we reduce it to 100. The model is created with 1,000 websites, but for the analysis purpose, we placed 100 images, and you can see those are got clustered in each areas of the matrix. And then we created a dendrograph to isolate the clusters, identify the clusters, and we got around 7 clusters identified, which we can clearly distinguish. And here we have placed examples of those layouts of the generated from the screenshots, and you can see there are by looking at it, we can see that in the rightmost side the search engine kind of web pages are there. Likewise, in the left side you can see some websites which have a grid layout, and likewise. So these are the 7 clusters we identified. So we have add some labels to for each of the clusters. So in the first cluster we got websites like which having a dashboard or overview or something like that kind of website. And as the second cluster we got the basic website which having a information page and a carousel window or banner, something like that. So those kind of websites are clustered into the second one. And the third, which have the product listing grid like eBay or eBay kind of websites, the product listing websites are clustered in the third one. And the fourth one, it has the blog-like websites which have a sidebar and information page in the middle. And in the fifth one, it got clustered the search engine like websites which have less elements in the page, just a search bar and a button like that. And the sixth one we got websites with a lot of columns and sections. And for the seventh one it got clustered the tabular data showing websites. And in the conclusion, so we have done several experiments with the manually created data and the real data, and we discovered that the lines which are representing the wireframe of a website is one of the core feature of overall web design. And other thing is, we we have done the experiment with SOM. We know that the SOM is a good approach to classify websites with the result of we found. And the other thing is, we know that websites can be classified by extracting the wireframe from those images by taking the screenshots of the website. So we know that also from this experiment. And as future works, we can do like we have already applied some image processing techniques to extract the data from the taken screenshots, and we can refine it more. We can apply more image processing techniques or changing the values, those kind of stuff. We can fine tune that. And the other thing is, we can try other aspects of also from the website. So we have just focused on the layout of the website. So in future we can check on other elements, buttons, drop downs, and navigation things, those also. And other than that, we can check on how we can auto generate websites using these this classification. So we have done the classification for existing websites. So based on that, we can utilize those classification in order to automatically generate website templates. Okay, thanks for all. And
okay, thank you. We can have a two quick. Yeah. We can have two quick questions since the time is.
Yeah, hello. When it comes to image processing, you may think about padding. So have you used any padding techniques over here? So you can sometimes when you like feed the images, you can miss out the edge pixels. So you may need to apply some padding techniques. So have you used any padding techniques in your research?
You mean to reduce noises or something like that?
No. Padding is used when it comes to edging pixels. The pixels in the edge, you apply some paddings to safeguard those pixels in the edge of the image. So you said like you are taking screenshots.
Yeah.
So you may lose some pixels in the edge of each website screenshots, right? So that's what I am asking, whether if you have utilized any padding techniques, padding.
Okay, you mean the actual image
Yeah.
elements which are in the website, right?
Yeah. The edge of the images, some wireframes can be there in the edge of the image, right? So padding techniques, so you just feeded the image into the model?
We didn't change any content or anything for the image. We just extracted, as I showed in each step, we took the grayscale image and we identified the lines, because a layout consists of horizontal and vertical lines. So we tried to extract those, apply the edge detection algorithms and to isolated horizontal and vertical lines. So by that, and we applied that small region removing methods also. So from that, there can be noises and small areas which, if there's an image also can have some elements and lines, edges. So those are also got removed. Sometimes it's not completely removed. If the image has a horizontal and vertical lines are in there, that's a limitation. Yeah, that's all we have done, but we didn't change the existing appearance of the website before that.
Okay. Have you applied any filters? So
Sorry?
filters, any filters?
Yeah, we have applied.
So I think like when you are applying the filters, you need to consider about the border pixels. So padding plays a vital role. So when applying filters, you may lose the border pixels, the edge of each images. So I think That's somewhat important.
I didn't get that actually. So when edge detection, are we getting that also?
Yeah, in edge detection, so in the edges there are some pictures, right? So if you have applied padding, then it would be clear, more clear. So when you apply filters, if you apply padding and then move those images into the filters, then you may not lose any pictures. So sometimes it may be vital on scanning wireframes.
Okay, I got it. You mean expand the actual image and get it.
Yeah, exactly.
Yeah, we didn't use that because we are focusing on the middle side, middle of the image. The layout represents the middle area. So in the edges, it has actually of all the all the images, it has the border line. We know that, and even we had the padding. I think the corner lines can be ignored because it's common for all the websites. So we are mainly focusing on the content side area of the wireframe.
Okay, thank you very much. So you can continue the discussion later.
Thank you.
Okay, thank you very much. So we'll have to finish the presentation. Thanks.
We thank all our presenters for their contribution. And now I cordially invite Professor Heva Gamage, the session chair, to award the certificates to the presenters. We now invite the following researchers on stage to receive their certificates. Gayanak Meemana, Sumeda Disanayaka,
Thank you, sir. Our next keynote speaker is Professor Timo Fort. Additionally, he leads the Networked Embedded Systems Group at Rice Computer Science in Stockholm. With an impressive body of work cited over 20,000 times and numerous Best Paper awards, Professor Timo's research centers on advancing low-power communication, particularly in the areas of backscatter communications and in-body networking. His contributions to the field are further recognized by the editorial roles on the IEEE IoT newsletter and the ACM transactions on the sensor networks. Ladies and gentlemen, please join me in giving a warm welcome to Professor Fort as he delivers his keynote presentation on low-power communication and in-body networking.
Thank you very much. Great, thank you very much for the intro. Thanks again for pronouncing my name correctly, which doesn't happen very often. Last year it happened too. So it's really, really great to be here. And actually I just confirmed with Kasun that it was 17 years ago that I met, Kenneth and also Kasun for the first time when they came to Sweden. At that time I looked roughly like this. Now you see it's looking a little bit differently. Is it better now? Okay, great. So you can start with the first slide. Okay, great. So as you may recall, I was here last year also, talked about something else. So short is the same, talk is something different. So today I will talk about towards 6G ambient IoT with backscatter and intermittent computing. So yeah, this was already said. I don't want to repeat too much, but what was not said, I have actually graduated 2 PhD students who did their undergrads here. Kasun Hevage, whom you will see This is Kasun, obviously, right? Kasun and also Dilushi this year. So I'm very happy that I got these great students from you. So I talk about 6G ambient IoT. So the Internet of Things, as you have also heard yesterday and today, many of the talks, has enabled a lot of applications. So we have personal ones. So the picture on the right is actually the heat pump we have at our summer house. It's actually not the heat pump, but it's the network for the heat pump. My wife controls the heat pad, the heat pump. I just control the network. So this is one application that has emerged. So we can control our gadgets, we can control our cars, we can do lots of things. Also, there are lots of societal and industrial networks. So we worked many years with this short-range technology, but then in the last 5-6 years also long-range, low-power communication technologies have popped up. There is, for example, LoRa that many of you have heard of. This is from the LoRa Alliance, and it uses the free radio spectrum, but there is also NB-IoT from the telcos, and that is now part of this cellular network. So what is then 6G ambient IoT? So that's the next initiative by the telcos, and they want to use this new opportunity of 6G to make IoT even better, more pervasive and everything. So there's a lot of standardization efforts in 5G advanced and 6G going on. So this leads me to the outline of my talk. I will talk a little bit about the background of 6G ambient IoT. Then I talk about an architecture called TADA that we have developed. And I discuss a little bit if this is an architecture for ambient IoT. Then I talk about harmonic backscatter. And at the end, I have many slides with open questions and things that we are currently working on from this direction. And I have to apologize, there is not very much AI in this talk. So 6G ambient IoT, as I said, this is one of the initiatives from the telcos. And earlier this was called by Ericsson Zero Energy IoT devices, the ambient IoT devices. And they communicate with a technology called backscatter, similar to RFID, that I talked about last year a little bit. And they also are powered by energy harvesting. So this means they have to survive times where there is no energy available that they can harvest. So energy harvesting, you know, batteries always cause problems. It's said that 20% of the IoT devices don't work because they are running out of energy. So one obvious solution is to just harvest energy from the environment. But is it simple? No, unfortunately, it's not very simple because energy from the environment usually comes and goes. This means that nodes, they may run out of energy, they may lose their state, they may need to reboot, and hence the application doesn't make any progress. And in many cases, there are situations where you cannot harvest very much energy from the environment. So here's a picture where I want to illustrate this. So on the x-axis we have time, on the y-axis we have energy. So we have a device that is powered by energy harvesting. There is some energy available, so it can charge up. Then it reaches a startup threshold where there is enough energy available so that the device can run. So then it can run and executes what it's supposed to do. But at some point it has used up all the energy, and the available voltage goes beyond the operating threshold. So this means that device needs to shut down. Then there is some energy available again, so the device can can charge. After a while, it can reboot, and then it can start running again. And this cycle is, you know, continuing and continuing. So here's a slide that you also may saw last year, and it's actually a 3-year-old slide, except for the last 2 lines. So basically, the approach for battery IoT that we set up earlier in our research group was We think that if we really want to do battery-free IoT, then you have to have two technologies. One of them is called backscatter communication, and that drastically reduces the energy consumption in a similar style as RFID does. So what you do is you outsource the energy-consuming task of generating a radio device to a radio wave to another device. So you have a device that generates a carrier wave. This is just a plain radio wave. Then this backscatter tag, it modulates its own data on top of this wave. And then the wave is received by the receiver. Intermittent computing is the other side of the coin. So here what we're trying to do is we try to avoid that we're losing the state when we have to shut down and reboot. So what we're doing is before we run out of energy, we are saving the state on so-called non-volatile memory. This is memory that doesn't need any energy. So before we run out of energy, we save the state, and then we reload this persistent state when we're booting again. And we think that this is the way to go to become battery-free. And actually, it turns out that, in 6G IoT, these are also two of the main components, which was, of course, very nice for us because everything we have done in the last 4 or 5 years, we can reuse in the context of ambient IoT. So the guys from the 3GPP, that's the standardization committee from the telcos, they're working on this standard. It's actually not yet a standard. They started with some use cases, and there is kind of typical use cases we had in the area of sensor networking for a long time. There's the inventory use case, automatic warehousing, logistics, supply chain, etc. Then we have command to activate, deactivate devices, electronic shelf labels and related things. Trackings to find lost items, positioning, location services, and sensing in smart homes, smart agricultures, and smart grids. So these are the use cases that the guys from 6G Ambient IoT foresee. So you can look here at some of the performance requirements. Very notably is that we have low data rates. The message sizes are not really, really high. But the coverage, I think, is kind of expected to be high if you're looking at the very right column. 500 meters for kind of devices that run with almost no energy is kind of a lot. The latency is, of course, very high compared to what we saw yesterday in 5G, right? They want to have these milliseconds latencies for, electric cars. This is, of course, nothing we have here, right? Instead, we have much higher latencies. On the other hand, we have device densities that are kind of high. So there's two main topologies. One is where the ambient IoT device talks directly to a base station, but then we have also the use cases where we may have a mobile phone that is also taking part in this topology and providing the carrier wave to the ambient IoT device. So here are the three classes of devices that 6G Ambient IoT defines. So there is a passive device, device A, that uses backscatter technology, and as you see, the power consumption should be around 1 microwatt, and that's really, really nothing. So I'm not sure if they can do very much with this. And device 2A is a semi-passive device. It uses backscatter. It has a reflection amplifier. This means that the incoming wave, the radio wave, will be amplified. And for this, you need some energy. So the energy consumption of this is a little bit, or the power consumption is expected to be much higher. And then we have a kind of traditional IoT device, an active device that has its own active radio. The energy storage is normally not normal batteries because of the size limitations, but they use capacitor or printed solid-state batteries. Design targets of this, we're trying to run on energy harvesting. We need very low power consumption. They talk about very small sizes, doesn't matter in all applications, and coexistence with legacy 3GPP, which means the normal telco network. And data rates are kind of low 5 kilobit per second, but still they're right, it's not really clear if such a high data rate is feasible. Emerging trends, so why do we want to collect all of this data? So the purpose of this ambient IoT is really to collect huge amount of data. Digital twins is one thing, right? We heard earlier in the keynote that there may be digital twins even of the human bodies, so that you can find out what medicine you would give to people and if there are any other effects with that. There are also AI-enabled sensors, right? So even so these devices are supposed to be really small and not very powerful, they still think we should run TinyML on this. Then the question is, what do you do on device? What do you do on the real network? And what this, as I mentioned, what this ambient IoT also requires is both intermittent computing and also approximate computing. So in the context of machine learning, approximation means the more energy you have, the more you compute, the more accurate become your results, right? So you start maybe with little energy and some not so very accurate results, but the more energy you gain, the more accurate you can become. And intermittent computing is that you want to survive these periods without energy by saving the state on non-volatile memory and reading it back. Great, so with this background on 6G ambient IoT, I want to present the work that we have done during the last year at Uppsala University. And this work was published at ACM Census, which is our main conference, the top conference where we really want to be. And the paper was presented just 2 days ago in China, but only 12 minutes, and here I can go a little bit longer and tell you a little bit more about this. So TADA is a task decoupling architecture for the battery-free Internet of Things. And the motivation for this work is that today IoT applications have very diverse requirements. Some requires a lot of I/O, input-output processing. If you're taking a picture with a camera, right, then you need to do a lot of I/O, or you want to communicate a lot with, for example, backscatter communications. Then we have signal processing that requires floating point operations, and also I mentioned TinyML. Right, today we have also MCUs for these really resource-constrained devices that have a like neural network accelerator, right? So they can also run inference on these really small devices. So what you see on this graph, we are looking at 3 examples, MCU or platforms, a normal ARM Cortex-M4, then an MSP 430, a very resource-constrained MCU that is running very slow but at very little energy, and an ARM Cortex-M4 that has an NPU, so that can run neural networking. We're looking at 3 different kind of workloads, right? A floating point arithmetic and 10 kilobit per second backscatter baseband generation for communication, and also machine learning inference. And what you see is on the y-axis how much energy each of these kind of workloads or tasks required. So you want to be very low here. But you can see also that there is no MCU that is good at everything, right? So they all require a lot of energy for a certain task, right? So the MSP 430 is not very good when it comes to floating point arithmetic. But for example, the 2 ARM cores, they are not good when it comes to generate the backscatter baseband. So the question, since there is no single MCU that's good at everything, the question is, how can we define an architecture that utilizes the best MCU for the tasks at hand? So you have this in mobile phones, right? If you look into a mobile phone, there is also some kind of digital signal processing. There is also an NPU that does neural networks, but for these resource-constrained devices, there is no architecture that is able to utilize the best MCU for everything it needs to do. And the goal of TADA is actually to do this. So here's an overview of TADA. So what Tada does, it splits it splits the whole application in tasks. These tasks has transaction semantics, so they run from the beginning to the end. When you take an image, you take the whole image, right, and not stop somewhere in the middle. But the application, this is what we don't provide the service of splitting the application in tasks. That's something that the developer needs to do at this point. And these tasks then exchange data asynchronously through a hardware interconnect that you can see on the top right. And this also has a non-volatile memory. So if there is no energy available, we have the data stored there. And also, this means that since we have this hardware interconnect, we can actually decouple task execution in space since we're running it on different MCUs. Also, thanks to the hardware interconnect with non-volatile memory, the MCUs need to be active at the same time. So the task execution can be decoupled in time. So let's look at an example. Assume that we're having an application where you first want to take a picture, right? Then on the top left, you would have the right MCU that takes the picture. Once the picture is taken, it stores the pixel values on the non-volatile memory. There is always enough energy to complete this whole task of taking the picture and writing it on non-volatile memory. Otherwise, we don't start the tasks. Then the data is on non-volatile memory. We have another task that wants to do the neural network processing based on this data to do something. So it will take the data out of this non-volatile memory. It will then run the machine learning classification or whatever algorithm it has on this MCU and write the result back on non-volatile memory. From where the last MCU, the one is that is very good at communication, can then take out the data and send it to the receiver. So this is an overview of this data architecture. We implemented this architecture, so we didn't have, so the interconnect is now an MSP430, the red platform on this image. And this has on-chip non-volatile memory. So one of the nice things about our architecture is also that the MCUs themselves don't need to have non-volatile memory. That's provided by the interconnect. We have a small software driver, about 1,000 lines, that has push, pull, and status function. There is one queue for each of the two MCUs that need to exchange data. Each MCU has its own capacitor as an energy source, and this is for itself and to run the interconnect so that both the MCU and the interconnect can be active at the same time. So for energy harvesting and the capacitor, each capacitor is designed so that it can actually execute the tasks and also write to the interconnect and maybe also read from the interconnect depending on where on the pipeline it is. And the capacitors are charged proportionally to the size if there is only one energy harvesting device for the whole platform. So we have developed some application prototypes, so 3 staple IoT applications to show that the system actually does what it's supposed to do. So the first one is an agricultural environment measurement application that does some sensing, then it does some processing, where it needs some floating point support, and then it transmits. Then we have a plant health monitoring application. So we first take a picture of a leaf, then there's a neural network that, based on this picture, infers the status of the plant, and then it transmits the status of the plant. And we have a human activity recognition that does some accelerometer readings when somebody is moving. Then there's a neural network that tries to figure out what the person is doing, and then the results is transmitted. A small remark here is that I had to exchange some of the pictures, and I took a picture from my own chili plant leaf, and we had some like minus degrees, which you probably are not so used to. and then one of the leaves looked like this, so the plant was not so happy about this minus degrees, I can say. Chili plants are not really used to minus degrees. So we had to do a manual partitioning of the task here. There is no support in Tada to do this for you. And we will do some pre-profiling to figure out which is the best MCU for each of the tasks. So here again, the application prototypes. We have the agricultural environment monitoring. Here we do first sensing and communication with one of the cortex, the one without neural network support, and then we're doing the wireless transmissions. For the other two applications, the human activity recognition and the plant health monitoring, we first do some sensing on the MSP430. This is taking the picture or taking the accelerometer data readings. Then we're doing some machine learning inference where we're using the MAX platform that has this neural network accelerator. And then again, we're doing the wireless transmission. So here are now some results. So from the energy performance, this is now done on real hardware. So first, the agriculture environment measurements. So here, the best single MCU which we compare to. So we're comparing now Tada against using the best single MCU for this. And we're showing the energy consumption for this. So here, Tada actually uses first the STM32, the Cortex-M4 for the flow point calculations, and then the MSP430 for wireless communication. And what you can see here that the energy consumption of Tada, or the energy savings, are around 75%. You can also see that you cannot see the green staple for the interconnect because that's the interconnect's energy consumption is very, very low. If we're now going to the next application, the human activity recognition, here the best performing single MCU is the one that actually is able to do neural network inference. And here the energy savings are even higher when you compare Tada with the best single MCU. Here we have energy savings of more than 95%. For the plant health monitoring, the results are not as good. We have lower savings, and this is because we need to do so much I/O for the sensing, where we have to take the picture. So these were the energy consumptions. We also look at throughput here, and this is important because it's not only about energy consumption, how much energy do you need, it's the question, how effectively can you actually use this energy? And that's what the throughput tells us. So here is the throughput is the number of completed application rounds over time. This means how long does it take a data item to fully traverse the pipeline from the sensing value to being transmitted to a receiver. This was a trace-based evaluation, so we used real-world traces that some other researchers had taken. So for the energy intake, so there is an indoor office with solar energy, outdoor stairs with solar energy, some piezoelectric sensors, or some piezoelectric energy harvester, and there's also a jogging person where the person was wearing multiple solar cells and some piezoelectric energy harvesters. So if we're looking at the throughput here and the average number of transmitted packets or completed application rounds, and again we can see that the throughput of Tada is actually much higher than of the single best performing MCU, and PHM, because of its lots of I/O, has a little bit of lower improvements. So in summary, so what Tada does, it enables developers to select the best MCUs for the tasks in battery-free IoT applications, so they can split their IoT applications in different tasks, and for each of these tasks, actually use the best MCU. They are connected with this interconnect that enables persistent state because it has non-volatile memory, and we have shown that using this, we're actually getting a much higher performance than the best single MCU. and we have very high energy gains, and we get much higher throughput. So in principle, this is something that is kind of obvious, right, that you could do something like this, but it has not been done before, and we have now shown how you can actually do it and how much you actually gain by doing this. So I talk a little bit about backscatter communications now, some work we have done. So as I said, backscatter communications, you avoid to generate your own radio wave because that's very expensive, but you're using an energy or radio wave that's already around, and if you want to send a 0 or 1, if you want to send a 1, you reflect the existing radio signal. If you want to have a 0, you just absorb the signal. This is kind of the simplest modulation, but there are also much more complex modulations possible. Let me just go on. So now I'll present some work on what we call harmonic backscattering. That's work that we have done with Ericsson together. There's a paper under submission currently now. So what normal backscattering does, it requires carrier leakage suppression. So in principle, you have this very strong carrier wave, and then you have the backscattered signal that is very weak. Now the receiver, like in RFID systems, if you transmit the carrier wave and you receive the backscattered signal on the same frequency, you have to put in a lot of work to distinguish this backscattered signal from the transmitted signal. So what we do in this work, this is more electrical engineering work. So there is first a mathematical model developed, then it is implemented in MATLAB. That's what many engineers always do, and then we evaluate the results. I'll be a bit quick on this, just a little bit again about the motivation and different possible setups. So the first setup is where we have the carrier emitter, which could in 6G contact, it could be the base station that transmit the illumination signal or the carrier wave. So illumination signal is kind of the telco wave for telco word for carrier wave. Then we have the backscatter device on the right-hand side. And rather than backscattering the signal on the same frequency, it uses harmonic, meaning the signal is backscattered on the double frequency. So this is a simple setup, which is called a monostatic setup, but there is also the bistatic setup, where the device that transmits the carrier wave is not the same as the receiver, but still there would be a direct link from the carrier emitter to the receiver, and we can avoid that this is on the same frequency as the illumination signal by using harmonics and double the frequency in that sense. And that's why it's called harmonic backscatter. So I have a slide with the results here. So on the x-axis, you have the signal-to-noise ratio. On the y-axis, you have the bit error rate. That has a little bit disappeared. Sorry, that's the bit error rate. So this means that if you are kind of lower, that's better, right? The bit energy, the bit error rate is lower here. So what you can also see is, so we have a lot of different curves here. The purple one, that's the harmonic backscattering. The other ones are the regular backscattering, which with different carrier leakage suppression, right? So if you have very high carrier leakage suppression, that is very costly in terms of energy and components. And what these results show is that you actually need a very, very strong carrier leakage suppression so that you're doing better than harmonic backscattering. So this shows that this harmonic backscattering is actually very, very useful. So this was kind of I talked about TADA, this architecture for like non-volatile, for devices that live on harvested energy and need to use non-volatile memory. I've talked a little bit about this harmonic backscattering, and one of the things that I think is that this TADA may actually be a really, really nice platform for 6G ambient IoT, because it actually has this non-volatile memory. It can also survive times when there is no energy available, right? You could use harmonic backscattering as kind of the wireless communication task that is there. So this means that TADA could actually be a very nice architecture. For example, it could be a plug-and-play architecture that if you want to use harmonic backscattering, you can use harmonic backscatter. If you want to use another wireless communication, you use another MCU that has support for this. So in this case, TADA could really be a nice plug-and-play architecture. And also these telcos, they usually focus on the communications, right? They do a lot of computations, how efficient is the communication that you do, but they focus not so much on the software that is running on the device. So that's why I think here TADA may actually play a very nice context. The question is it really, really useful? So I'm now coming to lots of open questions that I may have, that others may also have, that may be really nice research questions. So in principle, when you're using 6G Mbed IoT, right, so most probably you will use wireless power transfer as the energy harvesting method, right? If you have a device that should communicate its sensor data, the base station could first use wireless power transfer to give some energy to the device to charge its capacitors. But then the question is, if you do wireless power transfer, do you really need this interconnect? And, because you could actually give enough power to this so that it can execute the whole chain through all these different tasks. So in this context, does TADA provide some advantages? But on the other hand, maybe you don't want to use too much wireless power transfer because you want to use green energy, right? So if you have a device that also uses solar energy, maybe then actually TADA becomes very, very useful. And you could in addition use the weather reports to understand the harvesting conditions. How sunny is it? How much energy may I be able to harvest? Let me just see. And if you consider very large deployments, right, you have a number of base stations there, you have lots of small ambient IoT devices here. We know that backscatter has a not really large communication range, but wireless power transfer usually has an even shorter communication range. So maybe you can scale this by exploiting that. If you have a wireless power transfer from here, it may only reach this device, and this may be only these devices close to the base station. So this means you may actually be able to power several of these devices with different base stations at the same time. So this way you may be able to scale this and use more devices. And you also want to be scalable, so you want to transmit as little data as possible, because then you can schedule another device earlier. So that's maybe one thing why you want to run machine learning on these devices themselves, so that you can reduce the amount of data that you need to send. And this could enable you to do parallel interrogations in a much larger extent. But then the question is, how do you bootstrap this? How do you know which of the devices you are actually reaching without having too much chaos with all the devices, communicating at the same time? Something else that we are looking into, and actually this is Delushi, one of my students from this university here. That's her current work. So she's been working on analog sensor tags. So these are sensor tags that don't even have an MCU, right? Say they communicate by implementing the sensor value as a frequency shift. So a higher sensor value, a higher temperature would lead to a larger frequency shift. So here the frequency encodes the sensor values. And here one question that we are looking into currently is, if in having these very small ambient IoT devices, can we actually make this IoT device that is really, really resource constrained itself a gateway for some of these analog sensor tasks that are even more resource constrained. And if we're doing this, how do we handle this carrier wave that we need to transmit the data both from this really resource constrained analog sensor nets, analog sensor tags to this gateway, and then from the gateway to the base station? How do we doing this? Can we reuse it? Do we need to do some very nice scheduling technique there? So as I said, this is the work that Deluge is currently doing. So with this, I want to summarize my work. So I have presented you some background on this 6G ambient IoT. I presented this, what I think a very nice architecture, TADA as task decoupling architecture for this battery-free IoT and maybe also for the 6G ambient IoT. So this allows you to use the best MCU for each of the tasks that a normal IoT application consists of. It also provides persistent storage through this interconnect so that we can really work with energy harvesting devices. I talked a little bit about this harmonic backscattering and then some more thoughts on how to put this together. Can we get TADA? And is TADA a nice platform for the 6G ambient IoT? And then I provided some thoughts, ideas on the 6G ambient IoT, and these are things that we're looking into currently. So with this, I want to actually thank all my co-workers. This is not only my work, but the work of many people. And I also want to thank you for inviting me, having me here again. It's always a fantastic pleasure to be here in Colombo, seeing old friends and seeing new friends. So thank you much for the invite. And with this, I'm happy to take some questions. Oops. I know that I'm the last person between lunch, before lunch, but
Thank you, Timo. Before that, I need to announce that actually we are running with a big lead in our schedules, and apparently lunch is still not ready as well. So, so we have plenty of time for questions. So bring out all the questions you have. The question I have, Timo, is that this recently published work, TADA, or whatever the way you pronounce it.
TADA, TADA, you pronounce it whatever you want.
So this work is trying to maximize the use of multiple MCU units, right?
So this work allows you, if you have an application that you split into several tasks, to use the best MCU for each of the tasks, right? For example, if you have some machine learning, you want to use an MCU that has, neural network accelerator, right? As an example, right? And so far there has not been any platform that allows you to do this.
All right, and there's this trend of having many cores in microcontroller units. Probably not for MSP 430, but in STM32 series, I saw that there are like many core microcontrollers. How would that kind of architectures play a role in, let's say, in intermittent computing? Like, you have multiple cores running on multiple CPUs?
I guess that in the very long run, it would of course be nice to have something like this, right? As I mentioned, the mobile phone does it, right? There you have digital signals processors, you have neural network accelerators, but in this area we have not come so far, right? And you don't need this for all applications. For some applications you may not use it, but this is definitely a direction in which we are going, right? And also one of the nice things is that maybe even if you have those, they may not have support for non-volatile memory, right? So this, and our architecture also gives support for non-volatile memories to MCUs that don't have it.
Thank you, sir. I have a couple of questions.
Okay.
So how does using higher harmonic affects power efficiency and communication in practical deployment? And also I have, what are the practical trade-offs when deciding on harmonics for maximizing energy efficiency while ensuring reliable communication.
So for your last question, so there is almost no additional energy usage for providing the harmonics, because harmonics are usually generated whenever you do something, right? Harmonics are generated and typically they are not used, they are suppressed. So here we're basically using harmonics that may be generated anyway to communicate. And then what was the first question?
How does using higher harmonic affect power efficiency and communication range in practical deployment?
Right, so as I said, power consumption, right, that is not affected, but you're right, the higher harmonics, they are obviously at a higher live frequency, and this decreases the communication range. So what we have to pay is, as you probably have correctly thought, is that if we're using higher frequencies, like harmonics are at higher frequency, then we actually decrease the communication range.
And I have another question. How scalable is this application? Also, it can support large number of IoT devices. And how does it handle data storage, processing, and retrieval?
So what in this case, this is also a very good question. So in this case, you have very resource limited devices, right? So storage would probably be done at the edge of the network, at the base station, or even further in the network. Right, that was the, right, so this would, for storage, you would, I mean, many of the tasks, as was also said in the keynote yesterday, you would not do everything on the resource-constrained devices, but only when it's meaningful to do things on the resource-constrained device. Otherwise, like storage, you would try to put it as much as possible on the edge of the network. But then you may also do some, for example, neural network computations, or run your neural network or whatever, TinyML, on the node itself in order to be able to reduce the amount of data you need to transfer in order to save energy for that, right? Because typically communication is much more expensive than doing like computations. But with backscatter, this can actually shift, because backscatter now becomes really, really cheap. So maybe you want, in some cases, to communicate more data. So these are all trade-offs that depends on your applications that you're running.
Thank you, sir.
Thank you. Great, then I can add, I did not talk so much about machine learning, but there will be lots of, potential to use machine learning in this context. But I think there was now a question somewhere.
If it is okay, there's another question, yeah. So thank you for the words that we have shared with the 6G IoT. So it's very interesting. So my question is I think you have known Google, they have bought nuclear power plants for their computing power, and some other companies, the IT giants, they have bought nuclear power plants to support their data centers. So with this concern, so there's a concern about how to integrate and reduce the emissions and maintain the power, and as well as securing the ecosystem. So my question is how do you think how we are going to see how IoT can balance this carbon computing and as well as maintain the TADA architecture? So do you have any idea with this recent incident?
So if you want to reduce power consumption, right, as I tried to say, I mean, you can always use wireless power transfer from a base station that has enough power to power one of these devices. But it is, of course, more green and more scalable if the device has other possibilities to harvest from the energy, right? If it can use solar energy, right? Or if it can use harvest energy from vibration or whatever. So this, you're actually getting in something that is similar to, you know, this discussion, regenerative energies, right? Wind, solar power, they are not there all the time, right? But others like, you know, nuclear power, they are there all the time. So it's actually a similar discussion here than here on this low level of very small devices as for the whole energy system as a whole, right? So it's very similar in that context. One gives you guarantees, and the other one cannot really give you guarantees, because if there is not enough sun, you may not be able to harvest as much energy.
Yeah, that makes sense. Yeah.
So I have another question. So how can basic security functions such as encryptions, be designed to work under ultra low power conditions without compromising this performance?
Right, so very good question, also relating to what we heard yesterday, right? So yesterday the keynote speaker mentioned that, you know, security on these small devices is not really possible. Some things may not be possible, but there are hardware accelerators also for security, so these can be used. And then what can also be used is that you're looking into physical layer security. For example, whenever a device is transmitting, you can, with high probability, distinguish between different devices, because there's always some small discrepancies when the hardware was constructed, and this leads to something you can see in the wireless signal, and this is the so-called radio frequency fingerprinting. So these are technologies like this can also be used not for 100% security, but at least to authenticate with high probability if this device is actually a device that it is supposed to be. One question is, of course, also how much hardware support in terms of trusted execution environments we will have on these small resource-constrained devices. They will have something, some kind of specific key, right, like similar to a SIM card that, you know, that phones have, that allow you to bootstrap some security and do something on security. But again, the principle is you do what you can on the device, but then you may add something on the edge or at the base station to help you to provide the end-to-end security.
Thank you, sir.
Thank you very much. Very good question again.
Hello, I'm again. You mentioned Delushi, so I just wanted to know, like, she was a computer science undergrad, right?
Sorry, what?
You mentioned Delushi,
yeah.
One of your former PhD students. She did computer science, right? And the kind of research that you were describing were like more towards electrical engineering, as you mentioned. What do you think the learning curve from a computer science undergrad to the kind of research you are doing in the PhD level, how big that jump is? Can you enlighten us about it?
So that's a very good question. So my research was originally networking, you know, TCP IP stacks, web servers and stuff like this. But in the last years, I moved down the protocol stack. Now we are very close to the hardware. So Delushi has put some effort into, you know, like learning all this signal processing and lower layer stuff, but it was definitely possible and she likes it. And if you ask her now, she definitely thinks that, you know, radio frequency stuff is what she wants to do. So it is a bit of a learning, but I think we are kind of in a very nice sweet spot here that, I mean, we are working very close to what electric engineering is, but still we have a computer science background. So we do things a little bit differently than what the electric engineering people do it. We do it a little more kind of practical in that we also build our systems, we implement the software on these systems. This is what electric engineering people sometimes are not good at. So I think we can actually combine the best of the two worlds in that sense. But yeah, this is kind of at the border of electric engineering and also computer science. But of course, electric engineering people, they do also machine learning these days, right? So the border is not as clear as it maybe was some years back. Okay, I guess if there are no more questions, then I want to thank you again for your attention, and I want to thank you again for having me here again this year. Thank you very much. Okay.
Thank you, Professor Timo, for that insightful session. Yes, we have prepared a small token of appreciation, and we would like to invite Dr. Ruwan Veerasinghe to hand over this token. Thank you once again. We've had the pleasure of hearing from remarkable speakers and engaging in Science International Digital Investigation Journal. He further serves as a reviewer for various conferences and journals published by IEEE, ACM, Elsevier, and Springer. Ladies and gentlemen, please welcome the chair for the next session of paper presentations, Dr. A.P. Sayakara.
Okay, thank you everybody, and I know that you are still having your lunch, but with the interest of time, we'll move on. I hope you will join with us. In this session we have 3 papers. The first paper is titled A Prototype to Detect Alcohol Content in Local Toddy Based on Electronic Nose. This paper is going to be presented by Ms. KKI Nadishani. Nadishani is a full-stack software engineer with a BSc in computer science from the Department of Computer Science, University of Sri Jayawardenepura, and she has a BIT degree from the University of Colombo School of Computing. She's specializing in both front-end and back-end development and has a keen interest in applying machine learning to real-world challenges. Nadishani, the floor is yours. All right. Thank
you. Good afternoon, everyone. Today I'll be presenting a prototype for detecting alcohol content of local toddy using an electronic nose, and this is a collaborative effort with Professor R.G.N. Meegama from University of Sri Jayawardenepura. And this is the topic lineup for this presentation. So first of all, let's get to know about what toddy is. So toddy is a fermented beverage taken from the sap of palm tree. And there are 3 variations of toddy, namely coconut toddy, kittul toddy, and palm toddy. And also in Sri Lanka, toddy is not just a beverage, it's a part of our heritage, and it also forms a base for arak. And brands like All Reserve Arak, Ceylon Arak, and VSOA directly use toddy in their fermentation process of their brands. And as toddy production grows, it's crucial to monitor its quality, especially the alcohol content, in an accurate and affordable way. Maintaining consistent quality control is challenging, and this project aims to address that need. So traditionally, the alcohol content of toddy is measured using devices like ebullirometers. While these devices can be accurate, it usually takes time to give a result. And also, by the time you get a reading, the alcohol percentage of the samples might have already changed. But we can't track that with these devices because these devices does not provide continuous monitoring. It is only giving a static value for a specific time frame. But unfortunately, even with these drawbacks, the local toddy industry couldn't replace these devices because of the challenges like high cost, economic situation in our country, and also the import restrictions. So as a solution for that, developing an electronic nose that has ability to detect alcohol content in local toddy was proposed so that it will enable producers to measure alcohol levels accurately and continuously. And as for the related works, there were a review of previous researchers in electronic nose applications, and they revealed various classification and regression techniques. And as you can see here, these two researchers have used classification techniques for their data analysis part. And for these two researchers, they have used regression data analysis methods for their data analysis. And these studies provide a valuable insight that helped in choosing the right models to effectively work with the data. So the main objective here is to create a prototype that has the ability to detect alcohol content in local toddy. At the same time, make the device more cost effective and improve the accuracy and sensitivity so that the alcohol content changes can be identified. So this is the workflow for the methodology, and it includes 4 stages, namely device construction, experimental protocol, data collection, and data processing for predictions. As for the first stage, the device construction, it had 2 parts, creating the prototype and preparing the controlled environment. And for the device, 8 MQ series gas sensors were used. And in addition to that, a temperature and pressure sensors were included in the sensor matrix. And for the controlled environment, a confined chamber was created. So this is the experimental setup representation. And as for the next stage, in order to ensure accuracy, reliability, and consistency in those measurements of the prototype, some actions were taken, like careful sample collection, strict cleaning procedures, preheating process to stabilize sensors, and calibrations using non-alcohol percentages, and using a controlled environment, baseline establishments likewise. And for the data collection, all the outputs from those 8 MQ series sensors were recorded, and parallel to that, each recording includes the temperature and relative humidity. And also these data collection for a sample, it recorded over 20 minutes of time, including 600 recordings. From that, 2 data sets were prepared, one for the calibration purposes and the other one for predictions. So for the calibration data set, 8 samples of alcohol percentages were used. And as you can see here, these are the percentages that taken to the calibration data set. And from the complete calibration sample, 70% of them used as a training data set and 30% used as a testing data set. And for the prediction samples, 7 samples with 600 recordings from each sample were taken, and this includes 2 coconut toddy samples and 5 kittul toddy samples. And before moving to data analysis part, pre-processing techniques were applied in order to smooth the data and effectively removing noises and outliers for clearer analysis. So for that, a simple moving average filter with these modifications were used, and these are the modifications that applied for that moving average filter. And for the data analysis, these 4 methods, models were tried onto the calibration data set, and those are namely multiple linear regression, multiple nonlinear regression, extreme learning machines, and artificial neural network. And each of these models were cross-validated by applying cross-validation techniques to assess the accuracy of each model. So these are the results that has obtained by applying multiple linear regression with k-fold cross-validation on calibration data set. And as you can see here, the results were not satisfiable to move forward with this model for the predictions. Then tried on with multiple nonlinear regression. In here also it applied with k-fold cross-validation. But even with both logarithmic equation and polynomial equation, the results were not satisfiable for the predictions. Then tried on the extreme learning machine model with 100 nodes in the hidden layer. And here also I have tried 3 activation functions, a sigmoid function, hard limb, and sine function. And in this case also, this extreme learning machine model couldn't identify the hidden patterns of the data set. So in order to identify the hidden patterns of the data set and the complex patterns, artificial neural network model was applied on the data set. And it received a satisfiable outcome to move forward with that for the predictions, and it was run 3 times in order to ensure the performance matrix. So the artificial neural network model was used, taken forward with the predictions, and these are the prediction sample details. And as you can see here, these are the graphical representation of the predictions given on the sample, toddy samples from artificial neural network model. And here in this prototype, it provides a continuous monitoring techniques so that we can actually observe the fluctuations of the alcohol content of these samples. And unlike the traditional methods where the measurements only provide for a limited time frame, and it provides a static value, and here parallel to this device exposure to the samples, the traditional abeliometer method also applied on these same samples at the same time. But these traditional methods can only applied for a limited time period. The time was taken from the starting point up to 60 seconds. And you can see those values in red of these graphs. So as for the overall performance measures, by comparing to the traditional abeliometer method with the prototype, considering first 60 seconds, these were the overall performance measures. And as you can see, the mean accuracy percentage here, the prototype could obtain 93.45% of detecting alcohol content. And as for the overall performance, the prototype provide accurate and reliable measurements that align with the actual values with the mean accuracy level of 93.45%. So in summary, this electronic nose prototype allows for continuous monitoring of alcohol content in toddy, and it is accurate and cost effective, and hopefully it will offer a practical solution for small producers, enhancing their ability to maintain quality standards. But despite the efforts to improve the sensitivity of the device, it still may have limitations compared to commercially available electronic nozzles, and also its performance and accuracy might not match the high-end instruments because of the prioritization of affordability for small, practicality and affordability for small enterprises. And also the other factors such as market acceptance, manufacturing scalability, feasibility of mass production received limited attention in this research. And while the results seem promising, future work is needed, and future research will focus on model optimization and testing in real-world conditions, ultimately aiming for commercialization to meet the needs of local toddy industry. And these were the references that I've been using. And that concludes my presentation. Thank you.
Perfect. So we have about 6 minutes of Q&A time. So you can direct your questions to Nadishani now. Maybe while the audience is preparing, with some previous experiences I had with these MQ series sensors, one thing I know is that they have a preheat time, right? They need some, like you can't immediately power them on and use, like they need some time to settle down so that they are stable enough to use as a gas sensor. So I saw that you have used 10 minutes of preheat time. How did you decide that number?
Yeah, before using the sensor, it was instructed for those sensors to preheat up to 48 hours beforehand the experiments. So I was using that, and also 10 minutes. I did some researches on how to use properly, and likewise. So it was mentioned like about 10 minutes is enough. And also in order to the data for to settling in, when I used the moving average filter, I was initially using a larger window, about 200. So from that also, I was allowing the data to settling in for making a pattern.
Okay, sounds like a good strategy. Questions from the audience?
I have a question. So you are doing this for this prototype detect for the alcohol content for the local toddy. So how other alcoholic beverages you can use this prototype model?
So the main purpose here is to provide an electronic nose specifically designed for toddy, because that is, as I found, that's the industry gap here, because we already have numerous types of electronic noses, but one which specifically designed for toddy was not there yet. So that was the main objective here. Having said that, since those are gas sensors, we also can use those on other alcoholic beverages, but the model specifically trained to detect alcohol content in toddy. So therefore there might be different slight changes in the accuracy when you applied on other alcoholic beverages.
Thank you.
More questions? More questions? Another little input I can give you is like another thing to be careful about these kind of gas sensors, I would think, is like imperfections coming from the manufacturer. Like let's say you just buy one sensor, do all the tests, and if you buy another sample from the same like make and model, still I think there's a huge diversity in their sensitivity, etc. That's something.
Yes, to minimize that, but I mean we can't reduce that 100%, but to minimize that, I was using a matrix of sensors, not just one sensor. Then even if even one sensor received some outliers, in total, in combination of the output, the sensor matrix will give a satisfiable accuracy level.
Yeah, that's another good strategy, I would say. If there are no more questions, maybe we can move on. Okay, then thank you so much, Nadishani, for your presentation. Then we have the paper titled Investigating the Efficacy of Brain-Computer Interfaces in Enhancing Cognitive Abilities and Facilitating Direct Brain-to-Machine Communication. This paper is going to be presented by Ms. Geethanjana. I hope I'm correct. Geethanjana. So she is a fourth year software engineering undergraduate at General Sir John Kotalawala Defence University, and she is currently a trainee software engineer at Eternum Lanka, I would say. I hope I'm correct. Her research interests include artificial intelligence, artificial cognitive systems, and software engineering. So Ms. Geethanjana, floor is yours.
Good afternoon, everyone. I'm Adwa Geethanjana, and I'm here to present our review on investigating the efficacy of brain-computer interfaces in enhancing cognitive abilities to direct brain-to-machine communication. This review was conducted with the help of the mentioned co-authors. My co-authors and I conducted this research to identify the gaps in BCI systems and explore the potential of BCI to enhance cognitive skills, including how BCI systems can adopt artificial intelligence and artificial cognitive systems to facilitate seamless interaction between brain-to-machine communication. So these will be the contents that I'll be going through in my presentation. As Donald Knuth once said, computers are good at following instructions, but not at reading our mind. This quote captures the essence of brain-computer interfaces, or BCIs, which aim to bridge this gap by enabling direct communication between the brain and external devices. Brain-computer interfaces, or BCIs, are innovative assistive technologies that enable direct brain-to-machine communication between brain and external devices, bypassing traditional physical interactions. So our review investigates BCI's potential to improve cognitive functions like memory and attention, and their use in facilitating communication between the brain and machine. We also highlight how artificial intelligence and artificial cognitive abilities artificial cognitive systems can be integrated with BCIs to enhance accuracy, personal experience, and improve user outcomes. Our methodology began by identifying limitations in current BCIs, particularly in cognitive aspect, and to identify ways to enhance BCI's effectiveness through cognitive systems. For our literature search, we went through several electronic databases such as IEEE Explorer, PubMed, and Journal of Neural Engineering, focusing on the keywords brain-computer interfaces, cognitive enhancement, and direct brain-to-machine communication. Based on our inclusion criteria, papers published over the past 10 years that address cognitive enhancement or brain-to-machine communication, emphasizing neural engineering and AI-based BCIs were filtered out, and we used 37 papers for our review. We assess the quality of each study based on its relevance to our research questions and insight into neurotechnology and cognitive enhancement. The research questions formulated after our first screenings were: how can neurotechnology, particularly in BCIs, be used to enhance cognitive functions in individuals? How can cognitive capabilities be integrated into BCIs? How does the integration of BCI improve the efficacy and accuracy of direct brain-to-machine communication? And finally, a comparative analysis across BCI technologies summarizing findings on their effectiveness in boosting cognitive abilities and enabling brain-to-machine communication was conducted. And when discussing about brain-computer interfaces, there are several aspects that draws our attention. One is brain-inspired systems. So brain-inspired systems combined insights from brain science, AI, and brain-machine interfaces to create systems that simulate human brain processes, such as perception and learning, which could improve efficiency and interaction across various applications. And another aspect is brain-to-machine communication, which is achieved by processing brain signals to control external devices, making this technology essential for applications in prosthetics and rehabilitation. And then we have artificial cognitive systems, which aim to replicate human cognition functions such as perception, learning, reasoning, and decision making, which enables more adaptive and intelligent interaction. So our research review aimed to identify how these aspects interconnect and explore potential gaps and examine whether each aspect can support the other to improve the efficiency. Moving on to the applications of BCIs. BCIs have a range of applications, each targeting specific cognitive and physical needs. And one application is BCI in aiding human cognition. In enhancing human cognition, BCIs can monitor and boost cognitive functions like working memory. For instance, in the cognitive BCI prototype mentioned in the paper by Mora Sankes, which was built for continuous monitoring of visual working memory, achieved an impressive 81% accuracy in tracking visual working memory load, showing BCI's potential to support cognitive tracking and enhancement. But one of the limitations we identified of using BCIs to aid human cognition is the high variability in brain signals across individuals, which complicates consistent and accurate interpretation. And BCIs also help to empower individuals with physical impairments by allowing control over devices through brain signals. This is one of the main applications of BCI systems. This technology enables users to operate wheelchairs or other assistive devices without physical movement, providing greater independence. A general limitation of BCIs in aiding physical disabilities is the limited reliability and accuracy of brain signal interpretation, leading to inconsistent control, especially in dynamic or high-stress environments. So there's a research gap in exploring the integration of artificial cognitive capabilities into BCI control devices, which could actually enhance their functionalities in these dynamic and high-stress environment. BCIs also help for differently abled people, differently abled individuals, such as those with cognitive impairments, such as ADHD. BCIs can enhance attention, creativity, and overall cognitive abilities, helping individuals improve focus and interaction. A limitation of BCI is in aiding cognitive functions for differently abled people is the challenge of accurately defining and interpreting various patterns of brain activity related to specific intentions and tasks. And coming to application for BCI and mental models, BCI is aligned with the user's cognitive processes to create more seamless human-AI interaction, making these interfaces feel more initiative and responsive. A limitation of BCIs in relation to mental models is the challenge of ensuring cognitive fit between users and artificial systems. Because integrating AI doesn't simply mean that a system is the system has cognitive abilities. So ACS-based architectures can be used to define these models and improve artificial cognition. And finally, in the field of robotics, combined with artificial cognitive systems, BCIs enable robots to interpret brain signals in real time, allowing robots to respond naturally to human intentions. In the field of robotics, there has been a significant improvement in including artificial cognitive architectures to robotics, but the integration of BCIs along with ACS systems is an approach that needs to be studied in depth. Other than the mentioned main fields, integration of AI and artificial cognition with BCI can help to improve many other areas. So BCI alone has an impact on these areas, such as BCIs enables users to improve their cognitive abilities and express creativity, moving beyond traditional communication functions. Currently, a certain extent of improvement can be seen in these areas which is achieved through advancements driven by collaboration across diverse fields, such as cognitive and neural sciences, which are essential for developing effective brain-machine connections. These advancements in BCI also facilitate personalized therapy and robotic control, significantly improving interactions between humans and robots. However, this can be further improved by integrating AI and artificial cognitive architectures into BCI framework, allowing BCIs to deliver tailored cognitive strategies that enhance both user experience and therapeutic effectiveness. Overall, all these fields and applications influenced by BCI systems involve the development of advanced systems. To enhance these systems, from a cognitive perspective, they need integration of artificial cognitive architectures such as SOAR, ACTar, or Darwin. So by exploring approaches to integrate these architectures into BCI, we can achieve improved outcomes in helping those with disabilities, enhancing cognitive functions, encouraging creativity, and advancing robotic interactions. As for the future works, research should focus on developing adaptive BCIs, incorporating AI and artificial cognition to personalize cognitive enhancement techniques based on real-time cognitive states such as memory or attention. Additionally, establishing frameworks for ethical BCIs by using covering aspects like data security and informed consent is essential, particularly for sensitive areas like mental health. In conclusion, BCIs, particularly when combined with artificial cognitive systems, have the potential to significantly enhance cognitive function, assist in motor rehabilitation, and improve interaction between humans and robots. However, further research is necessary to address these existing limitations to ensure responsible development and application. So these are the references we used for our review. That concludes my presentation. Thank you.
Okay, thank you. So this is a systematic literature survey,
Yes.
which is something we don't frequently see in conference setting. Questions from the audience? We have plenty of time, actually. Not plenty, but we have time than usual. So, what happened to our, eager questioners? Or I don't know, how should I say that? Okay, yeah, while someone prepare their question, so these PCIs work with EEG signals, aren't they? Or are there any other source of information?
So, from our literature review, there are some EEG based ones as well. What we mainly focused on was to identify how currently they have used artificial intelligence in BCIs to improve its functionalities.
Yeah, so, okay, so, yeah, so adding up with, whatever we have been seeing and hearing last, yesterday and today, so I think in application scenarios that you have been talking about, rehabilitation, healthcare kind of applications, probably these brain signals need to be processed then and there instead of collecting them for a long time and storing somewhere in a resourceful server. So probably, have you seen in your survey equipment, like hardware equipment, that BCI equipment that has embedded ML, or being able to process this data as a wearable?
Yeah, so in most of the papers that we reviewed, they have these hardware components where they have integrated different ML modules as well. So what we are actually focusing is, so they have this general approach of using ML models or other artificial intelligence approaches to enhance these models. And we are suggesting to go in another approach to use artificial cognitive architectures to these models to integrate more cognitive abilities.
Strange silence from this audience. Okay, Timo, go ahead.
Thank you very much. Nice work. I had just a comment on just some stuff that we are doing at Uppsala University. So I have some colleagues who work on this, and it's actually easy to read out the signal from the brain to control a prosthesis. What is then the real challenge is to kind of understand that you're grabbing something and how hard you actually grab it, right? So this feedback that you get is very, very difficult to achieve. Like, as I said, controlling a prosthesis with an implant in the brain, reading out what the person wants to do is kind of easy. It takes apparently 2 or 3 weeks, then people can quite well control the prosthesis. But then getting the feedback back into the brain is apparently a challenge. That was more a comment than a question.
So in that case, the processing has to be done on the wheelchair itself, like whatever the wearable there. Of course, the manufacturer would love to send it to some cloud so that they can keep the control of the product, I guess. Directly done on the chair itself. All right. If there are no more questions to Geethanjana, then we'll say thank you. Thank you, Geethanjana. Okay. So our last presenter in this session is presenting this paper titled Securing IoT Servers, Strategies for Employing Shallow and Deep Neural Networks. Our presenter is Mr. Niranjan. Mr. Niranjan is a cybersecurity and AI researcher with expertise in deep learning, IoT, edge computing. He's holding a master's degree in IT with a focus on cybersecurity from SLIT. And Mr. Niranjan has worked extensively on projects designing design and technology education, emphasizing youth development in Sri Lanka. So he's currently a PhD student at SLIT, and his research focuses on enhancing the security of autonomous vehicle communication and low resource edge applications using AI-driven solutions. Okay, Mr. Niranjan, the floor is yours.
Securing IoT servers, shallow versus deep neural network architectures. My name is Niranjan Megamana and my other author is Harinda Fernando. So, application servers in IoT environments, we can also call them like edge servers. They perform data aggregation and processing, and they manage multiple protocol communications like web, sometimes MQTT and that kind of communications, and enforce security for device interactions at low level. They manage devices, firmware updates and configurations, ensure interoperability and seamless operation. Perform real-time monitoring and alerts. You can see there's a red circle. That is a typical IoT server. Now, these IoT servers, these are like Raspberry Pis, small ones, which are connected to multiple sensors, maybe wireless or wired. They face some critical challenges from network attacks because there is no perimeter security, physically much open in most of the cases. So, IDS and firewalls struggle to mitigate these attacks, our traditional approaches. So, because they have unique network topologies, for example, autonomous cars, their topologies are dynamic, always moving, and devices are heterogenic. They come from various manufacturers. And they have a resource limitation, very small devices. This study investigates shallow and deep neural networks for detecting these attacks. Now, when we say shallow and deep, our traditional interpretation is classical machine learning is shallow and deep learning is deep. This is not that. This is within deep learning. Shallow is wider networks and deep is more layers. So, the objective is to develop shallow and deep neural network models. We started with ANN, simplest form, and prepare a balanced data set. Now, this is one of the problems in many research. Lot of data they use, they are not balancing. So, it has an ethical issue, sometimes data distribution issue. So, it contributes to like overfitting. So, balancing data set is a major activity, and test the shallow and deep neural network models and compare and evaluate their performances. So, the methodology. Now, since we are creating and testing different models, we are very careful about the methodology. If there is any issue with the methodology, our results will be, they will not be very good. So, we followed machine learning pipeline exactly. First, balance the UNSW NV15 dataset is one of the best datasets for IoT recently, but there are some new datasets that have come recently, but until that time it was best. Create dataset with 20 significant features. Now, we did some different analysis like information gain and correlations to identify best 20 features because we want to make it simple. And also we selected from the same dataset 40 numeric features. We dropped the categorical features and did data normalization. When you do data normalization, the data, even if they have different ranges, we are bringing them down to a standard range so that when we are analyzing and interpreting, they will, none will influence the model more than the other. So, normalization is an important step. Then we split data into training, validation and testing. Actually, we use 90% for training, 5% for validation and 5% for testing. Validation was used to, during the training, to understand how the model will converge, how the accuracies and losses are changing. Then we designed shallow and deep models and constructed 4 shallow and deep models. I will explain it later. And did hyperparameter tuning of 4 models to find their best settings for training. And train the models, then testing models. And testing was 2 types of testing. One is the performance testing. The other one was a resource utilization testing. Because a lot of research are overlooking this resource utilization testing. You get better results, better performance, but your performance, it uses more memory, it uses more processing power. So you have to check both of these to create a evaluation which might be a trade-off at the end. So analyze and document the results. So these are the 2 models that we selected. The forward shallow model, it had only one single hidden layer. It had 512 neurons. We are inputting the same data, but only one single layer. Then the deep model had 7 layers, 256, 128, 64, 32, 16, 8 and 4. It's getting a number of neurons overall are much closer. But the deep model is more complex and it can recognize instinct patterns, while shallow model will expect to work very fast in detecting patterns. So how do we create 4 models? First we created 40 feature data set and applied those 2 to shallow and deep 40 so that we got 2 models, and also 20 significant features for shallow 20 and deep 20, that is shallow and deep. Why we had this varying complexity was we wanted to see how different model structure and different data sets would perform in our evaluation. So the hyperparameters used were these, ReLU, TAN, leaky RLU for activation func, optimizers, ADAM, RANSTOP, and learning rates, different learning rates, weight initialization, different batch sizes. It's a true experimentation to find the best parameters for each model. And those best parameters we applied when training the model. The training results for each model was like that. Training accuracy, you can see the models converge at different number of epochs, like shallow 20 at 40 and deep 20 at somewhere around 90. Similarly, we wanted to find out the exact place where it will converge best, comparing the accuracy and the loss. Otherwise, if we leave it for larger number of epochs, it will go overfitting, so that we can stop at that particular point when it is no longer improving. So the performance of models, shallow 20, deep 20, shallow 40 and deep 40 I explained earlier. You can see the shallow 20 only training time 289 seconds, while deep 40 962 seconds with the data set. And maximum validation accuracy 0.93 and 98 max. Similarly, end epochs, maximum validation loss. Maximum validation loss was highest, best in, not highest, it's the lowest, but best in deep 40. Similarly, we obtained test accuracy, precision, recall F1 score, because this is a classification task, and average precision. Where the conclusion. So we found the deep 40 model, which had 40 features and deep model with 7 layers. It performs best with superior accuracy of 98% in classification and generalization. However, it demands more computational power. Shallow 20 model provide moderate accuracy with low resource needs. Resource efficiency with reduced accuracy of 93%. So why we should select 93% over 98%? Now you can see sometimes the security requirements. Now I now connect this one to cybersecurity because I come from cybersecurity area. This purpose is cybersecurity. Now when you are looking at a say moving vehicle or a IoT, mission critical IoT, which is time sensitive application, it requires performance more than security. So that time we can use the shallow model with little trading off the security with performance. But where you need high security application like healthcare or similar application where we have time and resources, we can go for a deep 40 model. Now this contribution for this research, it introduces a flexible dynamic model strategy for IoT security, and future research is how we can use hybrid, how we can use these two models as hybrids for adaptive edge server protection. I'm already working on a journal paper which will adapt the use of 4 different models based on the dynamic security levels. Like if there are more requests coming, you fall back to the shallow model. When there are less stress on the system, you move up on the security. So that is the next level. So this is a conference paper. So I'll be doing the other paper based on that, continuing this hybrid model into how it can be used in autonomous vehicle communication security environments. Thank you.
All right, thank you. Questions from the audience? We have time. Now it's the last presentation of this session. We have time. Questions?
Can you specify about the loss functions that you have used over here? Have you kept the loss functions common for all the 4 models?
I cannot, I must go back to my, hold on, I must go back to my presentation. Can you put the presentation? Hyperparameter tuning, it is not here, right? These were the function, but loss function I cannot remember. Sorry, I cannot remember technical detail. I'm very sorry. But loss function is documented in my coding. I cannot remember that right now. Sorry. Okay. I must go into my documents
There's a question
to answer that question. It's not here. Thank you.
Yes, so one question. So this is a grid search, right? So that's like a massive search space, especially if it is 7 fully connected layers.
No, I use the random search because the grid search actually gets stuck on the way within my environment. So I use random search for this one with I think hyperparameter tuning. I did use random search with Keras.
And these are 7 layers in the deeper model, right?
Yes.
All fully connected.
Yes.
Why didn't you try any other architecture than fully, dense networks?
No, I wanted to, my research objective was to compare shallow and deep. So one shallow layer with 512 neurons And 7 layers, these 512 neurons are distributed as 256, 128, then 64, 32 and 16 and 8.
So owing to the vanishing gradient problem, we generally use other architectures, right? Like CNN, RNN, LSTM, that kind of thing.
No, I use ANN only. I
Yeah.
didn't change the model. I only use single model, that is artificial neural network. I didn't go for LSTM or CNN, other models, because then comparison will be difficult for me. It will be comparing models. I was comparing shallow and deep only.
Yeah, no, what I meant is because of this so-called vanishing gradient problem, when you backpropagate the errors, they become like, they underflow.
No, I use validation. That is why I carefully monitored the training using validation loss. When the loss was no longer reducing, or when the accuracy is no longer increasing, using a stopping function, so immediately the training was stopped. So by doing that, I mostly prevented the overfitting problem finally. Because it is actually not comparing different models, but comparing two different architectures, single layer and 7 layer.
We'll speak after.
Yeah, we can continue the discussion further.
Hey, I'm ready to discuss.
Any more questions? So in this work, you are trying to optimize the accuracy as well, the performance, as well as the computational overhead, because these are going to be IoT servers.
Yes.
They are supposed to be running on low-powered platforms, right?
Yes.
Yeah.
And this is the resource utilization data. That is, the model size is 110 KB for the shallow 20, and you can see 708 KB for the deep, so that it takes the memory. And when it comes to memory usage, this is 0.016 GB, the other one 0.021 GB. So there is a higher memory requirement for deep 40, and shallow is lesser. So that we can dynamically adapt to different IoT environments, these 4 models. That's the idea.
Okay. So if there are no more questions, let's thank Mr. Niranjan. Thank you for your presentation. Okay, with that, we are ending this session. Thank you so much for your attention.
We thank all our presenters for their contribution. And now I cordially invite Dr. Asankar, the session chair, to award the certificates to the presenters. We now invite the following researchers on stage to receive their certificates. Indumanada Ishani, Aduva Geetanjani, Niranjan Meegammana,
Thank you, sir. This announcement goes out to all the I Am a Researcher competition participants. Please note that all cash prizes will be transferred to the winners through the Dialogue Genie app. Hence, those who still have not downloaded are requested to visit the registration desk to complete the process. Our final keynote for today will be delivered by Professor Lothar K. Becker, a prominent advocate for open source software and a pioneer in the field of free office productivity tools. Professor Becker holds a master's degree in computer science and economics and completed one of the earliest master's theses in data mining and German Research Center for Artificial Intelligence. Throughout his career, Professor Becker and his company have been leading providers of services for StarOffice and OpenOffice organization, spearheading open source migration projects and certification initiatives using LibreOffice technology. During the pandemic, he served as a chair of the Document Foundation and currently sits on the board of the Open Source Business Alliance, where he continues to champion digital sovereignty in both private and public sectors. Today, he will explore the transformative implications of AI and open source software, with a particular focus on Copilot technologies and LibreOffice. Please join me in warmly welcoming Professor Lothar K. Becker.
Thank you very much for the kind introduction. So, open source, Copilots, AI. Last year we had, with a colleague and me, had the chance to introduce a little bit LibreOffice into the university with workshops before and after the conference. So afterwards, we experienced that you are very, very interested and active in artificial intelligence. And we thought about, well, AI is also an item for LibreOffice. And why it is an item, I want to explain a little bit. Afterwards, I have introduced a little bit in LibreOffice where it comes from. The Document Foundation, in behalf I'm talking to you today. And then I want to mention the way AI is brought to Office suites with these copilots, so-called copilots, which are today mostly done in cooperation with OpenAI. And I'm speaking in the headline of the talk of risk, so no fear. I don't want to blame OpenAI in any sense, but I want to ask the question if OpenAI is today the right decision for doing AI in the in the office productivity environment. So it's more an ethical question I want to raise here. Yes, I was introduced perfectly, so just a few words. I'm talking here on behalf of the Document Foundation. My background, I have a little bit background, it's history, to be honest, in the university with AI, so I'm very interested in these items and issues in office productivity, but my business is around all these migrations to LibreOffice, mostly from Microsoft Office to LibreOffice in industrial or governmental environment. So you can expect a deep look into industrial problems or needs. What I'm not anymore so familiar with is this academic level. So please hear a talk more out of practice, more out of industrial experience than on academic improvement or something like this. I think this could be a great job for you, and that's what I'm talking here, or why I'm talking here, to engage you to come into the community of open source and LibreOffice, engage with AI in LibreOffice, and do the best to bring the same functionality to LibreOffice as perhaps we experience with Microsoft Office these days. So what is Document Foundation? What is LibreOffice? First of all, LibreOffice is meanwhile, the second most used Office productivity suite in the world. We are a little bit proud of that, but to be honest, we have to be a little bit cautious with proclaiming this second most used Office suite, because we have, to speak in academic words, we have no fundamental amounts. Why do we not have? Because you can download LibreOffice for free and without registration. So we can estimate more or less from downloads or from, there are some other possibilities to do estimations on which different computers we are installed and how the measurements are. But I can't give you an exact amount of installations or deployments from LibreOffice. But we have agreed with studies that we are the second most on it. So behind LibreOffice, and this is important for the talk, behind LibreOffice there's the Document Foundation. As the label says, it's a foundation, and it's a foundation for good. So this is not a company making profit, it's a non-for-profit organization. And it mainly works because of people contribute to this project, to this foundation. And LibreOffice is, by the way, one of the projects the Document Foundation is hosting. There's another one which also explains what we are doing in the Document Foundation. This is the Document Liberation Project, which produces export and import filter for your documents produced on digital devices, mainly to bring it in the open document format. And I think the others are clear. We promote free software with free downloads. We care about digital sovereignty with users' freedom to choice. We bring a free and totally open document format to your computers. And we care about open standards. And open standards is also a very important issue in integrating, for example, AI functionality with the Office Productivity Suite. A little bit of history, perhaps you have seen some of these logos. I don't want to explain the whole story. There are some turnarounds and some cornerstones in the history. I just want to mention that the history of what is behind LibreOffice is also more than 30 years. So this is not, as often accused, open source projects, a small, little, tiny, just a few days done coding. No, it's really a long-time software project with a lot of people behind. To give you just a glimpse, we are round about 1,200 contributors, actively contributors. They are certainly not all have a job at the Document Foundation, but these are mostly volunteers privately or from companies who are bringing code, marketing, documentation, and all what you need to the project and to LibreOffice. So some of you know perhaps the brand StarOffice. This is the original root of LibreOffice. Then it went to openoffice.org, open. I want to mention the word open. And then it turned out by a milestone that we ended up today to the LibreOffice brand. So this was the beginning, no fear. Today it's looking in another user interface, but I want to show you, to prove you that this is a long history. And to be honest, as you have seen, I'm a German guy, there are one or two names in there I still know in Germany. So people are long-standing with this project. Yeah, not to mention a lot about the foundation. It's, as I said, a foundation for good under German law. What is worth mentioning that this construction or this organization as a foundation is very, very important. So German law sets the rules of the foundation, the rules for giving for good can't be changed anymore. Yes, there is a way to change them, but this is a very, very, very hard way to do. So what not could happen is, for example, that the non-for-profit property goes to for-profit. And now you get a little glimpse why I'm playing around with this OpenAI thing, because they have a story which is a kind of that. Who is interested in the foundation itself, how it works, how is the organization, can go to this website and have a look there. What is LibreOffice? It's an Office suite deployed with 5 modules, a text editor, a spreadsheet, a presentation module, a drawing module, and a desktop database. So these 3 were built up in the history as a productivity suite. Yes, no Outlook alternative. So we are working closely together, for example, with Thunderbird, Mozilla Thunderbird, the project in OpenOffice. But this is the pure Microsoft alternative with LibreOffice. And one of the first challenges we experienced, real challenges we experienced, not just in building all the modules with it, was the point where Microsoft went to cloud. Microsoft was going with Microsoft Office 365 to a browser-based collaboration installation, server-based, and then with the possibility in real time working together on documents. And nowadays we are lucky that beside the normal client installation, you perhaps know, we have the possibility to do the same document format in browser. And this is the reason why I'm talking about LibreOffice technology. So what's behind the browser-based LibreOffice could be named in other ways. For example, Collabora Office or Nextcloud Office. Later I will mention Nextcloud Office. These are other brands because of other UIs, other rendering functionalities in the browser, but under the hood, it's all LibreOffice. So there might be a different way to bring it to the client, to the worker, but under the hood of Office functionality is done with the core of LibreOffice, with LibreOffice technology. And certainly these days we have also mobile installations for viewers, or there are already some editing apps for LibreOffice, but to be honest, I don't know if it makes sense to do a calculation or a presentation on such a small device like a mobile phone. But the demand or the need is coming up more and more, so we need this as well. So what you should take from this is that we are on all devices meanwhile. This is done by different brands, but all LibreOffice technology. Now, I'm talking about the next challenge we are facing, and that's where you all come into the game. As we have reached the target, the object that we are also comparable with Microsoft Office 365, and by the way, I want to mention one thing. This is important. If you use Microsoft 365, your experience would be you are doing some stuff in it, and if you want to use a higher sophisticated functionality, you are brought directly from the browser version to your client version. This is not the case in the alternative. So you have all in the browser. And that's the idea behind my talk, that if we get also this co-pilot functionalities into this technology, we will far beyond Microsoft Office. I know this is a very, very ambitious sentence, but if we can do that, then we are really, really good. So why is this a challenge? To be honest, Microsoft Office did this since 2023, so they introduced these kind of co-pilots. You were experiencing this, that there were more and more coming in these kind of co-pilot functionalities for working with prompts. It's all with working with prompts in text, proposing a text, in summarizing text in it, or generating with ChatGPT any content in text documents and spreadsheets or in presentations. And what is going more and more is this how-tos, how-to-dos, pilots who are showing you the way how to do something. For example, what is one of the most used co-pilot is cleaning up my slides. So you can hit on such a co-pilot button and your slides are done very nice with all the same master slides within and so on. And this is done with the acquisition of OpenAI. To be honest, it's not a fully acquisition from Microsoft, but mostly one, done by closed models and parameters and training data. And with this, you have to pay an additional plan in Microsoft Office for using such pilots. So it's proprietary, and you have to pay a license fee, an additional license fee. But undoubtedly, out of my experience doing migrations in government and industry, this is a killer feature. One of the first questions I always ask when we go to government or go to industry corporations is, where are your co-pilots? Can you do this? Can you do that? And to be honest, our answer is there not really a fulfilling one. We have some answers there. I will give you a glimpse of it, but there's a lot of work to do there. And again, this is the point where you come into the game. Yeah, why is it so hip? And why we ask always the question, if we migrate to LibreOffice, do we have such co-pilots? And as a businessman, I must say, chapeau. If you have a look at this result of a study which Microsoft did, but I believe it, it's okay. They proclaim they gain in time per day with the use of co-pilots 30 to 35 minutes per work day. This is a huge productivity increase, a huge productivity increase. All managers who are seeing this say, oh, I want to have this, certainly. So this is a challenge for us to have also this functionality. So now I want to argue why we perhaps should it do in another way than Microsoft have done it. So I want to play a little bit with this open and AI. I think in this audience I don't tell you too much that the story of OpenAI was from really open. That was the reason why they called it OpenAI. It was a research-funded company, all for good, all open, and they get at a point, and now we can discuss for days, I don't want to question this, where they need a huge amount of capital for doing all this data learning stuff, model designing, and so on. So this was the point where Microsoft comes in 2019. They found a for-profit subsidiary, before they were non-for-profit. They found a for-profit subsidiary called OpenAI Global, and 49% of the shares, and additionally, the Azure Cloud technology was brought to OpenAI. And this was certainly the point in history, or the point in time where Microsoft said, okay, if we do that and we will use this in Microsoft Office technology or in Microsoft technology, then we have to change license agreements and we have to change fees and so on. So it went from open to proprietary, and with this move, OpenAI, or this research company, lost a lot of especially researcher, but also a lot of developer who said, no, this is no longer our company. We were hired with another ground, and we leave this company. This was a problem. So as it all is now with this model 4.0, I think, more or less closed, using this with the co-pilots is a loss of digital sovereignty with it. So what means digital sovereignty? Digital sovereignty means that the ability for every user, for government, for a company, to decide for what and how it to use. They want to use it for everything. They want to use it on every PC. For which purpose you can think about. They want to migrate or have the ability to migrate to an alternative at any time. Go to LibreOffice. It might be a way, but there's a question, where are your co-pilots? To process data in a transparent and secure way and verify it. This morning we heard from the Cambio CTO that is not just using it, but verifying content or results of AI. This is very, very important. With LibreOffice, with open source, with open data, you can verify if the model behind, the code behind, is really doing that, what they are proclaiming, or the data are not biased, or something like this. So this is digital sovereignty. And in the European country, this argument, especially in use with Microsoft Office, is coming up more and more. I have a discussion this morning where I said, the open source community did long time effort. We always argued with costs. Open source is for free, you can download it, scale up with every client. But the real thing why it's worth to use open source is this kind of digital sovereignty. There are a lot of examples. I think I do not need to mention something like Volkswagen, which they did with software, fooling the test with the software. So this is the reason why why it is, and MS6 chief Richard Moore said it in a good way. So the answer for keeping digital sovereignty is open source and open standards. So in European areas, we are faced with a huge wave. I know in the Asian countries it is a problematical picture, but I want to show you that this is very much important thing which is coming us, because everybody in industry or in government, more in government than in industry, is saying, okay, I want digital sovereignty, I want it now, and I want it all. So the demand is that when we proclaim digital sovereignty, but then we need to fulfill the same needs as Microsoft Office do, or the co-pilots with Microsoft Office. So what I want to do now is to go from the left side where the Office Productivity Suite is to the right side where the AI functionality could be coded, and where are the possibilities of integration with an Office suite, with LibreOffice, what you can do with it, what we have on examples with AI integration in LibreOffice, and where we see the main demand in the future to integrate AI functionality in LibreOffice. First of all, why is LibreOffice itself, or LibreOffice technology on these different devices, digital sovereign? Because it fulfills these four freedoms. Keep in mind these four freedoms. I will show you later a classification of ethical AI, and you will find some criteria of this as well. So first of all, the first freedom of open source is run the program as you wish for any purpose. You can download it, you can do it without restrictions and without registrations. Nobody wants to know who you are, for what are you downloading the software, and for what. To study it, how it works, this is the transparency, to look into the code, to look into the algorithms, and to verify that no data is going out anywhere, especially not to US. To share copies of it, yeah? You are allowed to scale up in the whole university, every PC or client to deploy a LibreOffice installation. This cares nobody. And ahead of this, you are also allowed to redistribute changes of the source code which you have done by your own. Be careful, there are some open source license constructions which are handling this a little bit slightly different, because there are some demands that if you are changing the source code of an open source software, they demand that you give these changes as open source as well. But there are different levels of open source license agreements, and this one, what LibreOffice is using, it's completely free what you do. Even if you are doing it with a proprietary one. If you integrate it with proprietary software, you are allowed to do this. And we will see exactly this with OpenAI. Yeah, second thing is, I mentioned it, it's the open document format, which is totally, completely open and free, which is to be honest, and this was what Italo explained last year, the open document format, the native document format from LibreOffice is a completely free XML-based document format, and not with binary parts in it because of backward compatibility or something like this, which are 99.9% of all documents which Microsoft Office produce. So now I come to the, I make the step in the middle and want to just mention the possibilities how to integrate into LibreOffice, which would be the interface for programming, or maybe the interface for programming with AI tools and the Office suite. So first of all, this is really an easy one. This is the interface in the command line. You are able to use the Office suite and perform tasks, more or less all tasks you can do in this Office suite from command line. You can give a command line statement with a lot of parameters behind and can do a lot of things in this. So the easiest integration level, or the lowest, is via the command line integration. More often, you can find integration via these functionality enhancing with extensions. So you can bring in this Office suite a kind of piece which have code in it, mostly these days Python code. Python is very important in combination with AI stuff. You have a lot of libraries which you can use in and use it here within LibreOffice then, and bring this functionality into LibreOffice itself. So you can enhance UI, you can enhance, you can take the prompt, for example, out and produce content into the documents and so on. So this is the second, more sophisticated level with logic in it. But I think the most reasonable level of integration is this with a universal network objects layer. What LibreOffice has, a totally open API. This is an API, and behind the API is an object model. So the first level is shown over there, but you can imagine that this is really, really complex behind these shown nodes, with which you can interact with mostly all programming languages. There are binding bridges with which you can, out of C++, from Python, from Java, or what you want, interact with this Office suite. So, for example, if you want to analyze all data which your company have stored in the open document format, you can do functionality who is scanning all these documents, putting out the content, doing something with this, for example, learning, and also manipulate this. This is a very, very complex API, to be honest. This is described in a lot of websites. I mentioned the one, a lot of documentations, 1,500 pages or something like this, and this is hard stuff. Before I show you at which level we have already solutions with AI, I want to mention, out of experience, where do we need such AI functionality in Office productivity suites? And what I was wondering, that these 4 categories, out of experience, were mostly fitting with these 5 or 6 levels, the Cambio CTO was presenting this morning. And I can assure that the most, or the up-to-date integrations, Microsoft Office with its Copilot is slightly on this level, but we with LibreOffice can do some stuff in this generative AI level. So something like recognition and producing, summarizing document content is possible in text, audio, graphic, and video. Speech is a kind of problem and will need a lot of integration work with AI models who are able to handle speech recognition or the transforming to text. The more sophisticated is AI assistant pilot performing functions for layouting, pattern learning. This is this button click, clean my presentation, all with the same master slides and so on. Therefore, there is no solution up to now, so work to do. But what also is where we are working on is this pattern learning over used styles and templates. So we are looking at the user behavior, what they are doing, and trying to combine some activities for one clicking for help the users doing some layouting or something like this quicker. This comes with now again an experience out of the industry, out of the practice. This comes with one, the positive side is you can gain productivity. The negative side is that you start to obscure functionality from the user. Why is this important? Because if the user wants to do a slightly different master slide, he never knows anymore how to do this. So this is one, but this is a general problem. Next one is data mining and knowledge management. We have heard some paper demonstrations today, I think, for knowledge graphs and so on. This is this level. Automatically learn from behavior, from content, document content, sorry, and doing something like a knowledge graph and knowledge management for the company or for the government. And the highest level is this meant in the sense of software robots, where there are some co-pilots behind every special worker, recognizing what they are doing and automate such a workflow by themselves, supervised or unsupervised. In the best case, they will do the work unsupervised so that, for example, a granting and support for a customer is done without interaction of any human being anymore. We are far away from there, but this should be one target. I think there are some models, AI models there, which can organize such things, but we have to do the integration work. So I promised you to give you a few examples of what we are already doing with LibreOffice technology. Again, this is work done in industry or in government. For example, one of our very active member, Asian Mektor Rania Amina, he's Indonesian. He was the first one, I think 1.5 years ago, who brought in this prompt from OpenAI to LibreOffice. So as you could see here, I have labeled this with hybrid or full digital sovereignty. Because using OpenAI, you don't know what is, if you have the API to OpenAI, the content is going to their servers and you don't exactly know what they are doing with it. So this is a hybrid way. But he did also the same interface with the Google AI Studio. So not all open source, but a lot more open source than OpenAI. There is a quite similar extension for Writer, for the text editor, from Zara Hatami. You can find this in the YouTube channel, and from there where you can find the code, with a Python integration, which is also a prompting thing, but you can do first steps in, for example, in summarizing content of a document. If you have 40 pages document, then you can ask for, give me a summary of these next 40 pages, and print it on the text document. There are other extensions which you can find on this extension website from LibreOffice. And there are now some more open AI solutions with LibreOffice. As I mentioned, Nextcloud is one of a big contributor to LibreOffice. Why? Because Nextcloud Office itself is LibreOffice technology. So behind Nextcloud Office is LibreOffice. And what they are doing is they are integrating AI assistants, like I've mentioned in these 4 categories, more and more. They are really, really doing a great job in integrating this in Nextcloud Office. Another example is a very famous project in Europe nowadays. That is the government of Schleswig-Holstein. Schleswig-Holstein is a northern country of Germany, regional state administration, who is completely migrating 30,000 clients to open source. So all administration workers are working on open source clients, also with Nextcloud. And what they are doing for them is a kind of what I've mentioned, that they try to find workflow, to learn about workflows, document workflows, and automate them. This is an early stage, but I'm convinced that they will bring a lot of more productivity to Schleswig-Holstein. A kind of similar activity is OpenDesk. OpenDesk is a brand, no, it's gone. It's OpenDesk from the Center of Digital Sovereignty in Germany. It's a so-called open source project office of the government of Germany. And this is based on technology from Nextcloud and this project, and they are pooling fundings for enhancing this. To be honest, there's not the problem of money. There's the problem of know-how. And again, this is where you come into the game. And last but not least, what I experienced at the beginning of this year is that the government of Taiwan is something quite similar. They are developing an integrated solution, but they want to have a pre-trained basic AI model which is running locally, operated locally, so that on any PC of a so-called special administration worker can use AI functionality just without connectivity to a server or to the cloud, just on the PC. So this is hard stuff, I know, and they are struggling with hardware restrictions on the client side, but they are working on it. And all upstream, what means it's open source. At the time when it's working, you can take it, you can innovate on that. The other thing what I want to, or what I have mentioned, is this ethical AI ranking. So every extension, every functionality which is coming in through Nextcloud, they have done such an easy but meaningful classification for ethical reasons. So everybody who is using such an extension can decide by himself if it is okay. So here are 3 categories or 3 questions. First is the software open source, both for interferencing and training? Second one is trained model freely available for self-hosting? Third one is the training data available and free to use? And then they are giving all these extensions, this functionality, a green, a yellow, orange, or a red one button, so you can see, okay, if it is labeled red, nothing from this is fulfilled, is done. So it's on your choice, it's transparent, and it's on your choice if you want to do that or not. Or if you are in an environment where it is appropriate, perhaps just use features which are labeled green. Yeah, this is the mentioned Schleswig-Holstein project, 30,000 clients. I want to skip these. This is the look of this standardized IT workstation, which is completely, when it is fulfilled, completely open source. You find some logos here. You see that one of these columns are LibreOffice, which will be enhanced with these artificial intelligence functionalities. Others here you can see there's some Nextcloud, Mozilla, Open Exchange as Exchange, Microsoft Exchange substitution, and so on. So, the journey in artificial intelligence have just begun. We are very, very in our first steps, and we need know-how, we need persons, we need students, we need researchers who are able to do AI stuff and who are able to integrate this into LibreOffice. And this was the reason why I've given you just a glimpse what is meant with integrate in LibreOffice. And I think we have seen some paper demonstrations which are perfectly fitting in this. Bringing this functionality was what was researched there with an integration into LibreOffice and then get used. Some text summarizing, learning, and so on. So what are the opportunities for joining these efforts? Mainly 3. Certainly not just individuals, but also ecosystem partners. I've discussed this with Cambio during the lunch, how they can use LibreOffice instead of Microsoft Office. So get involved with the community. What is very, very important to know is that the Document Foundation is giving some help with development coaches. These development coaches are very fluent in this integration and this object model and so on, but they don't know so exactly, and that's, again, you, what to do with AI models and how to develop them, how to code them, and so on. So we can bring in help to learn how you can integrate in LibreOffice. And you can bring in the AI know-how and how to get AI software in it. There are a lot of job offers in Asia, mainly in Europe, with these job skills asked for. Have a look at this website. By the way, if you want to have the slides, there are a lot of websites. Please give me an email. The last slide is with an email address. So give me an email. I will deliver to you so that you can have a look in these websites. And also as student, there are possibilities. For example, in Google Summer of Code, we are engaged with the Document Foundation. We have own projects funded by foundation money, or we have all possibilities for asking these development coaches if you want to do it at the university. Then also there's a possibility to have a coach at the Document Foundation for this integration stuff. If you want to know more, then go to the website, what can I do for LibreOffice tutorial? Easy Hacks, there's a website in the wiki of Document Foundation where Easy Hacks, this is not just AI stuff, but everything else, to come into the code of LibreOffice, to doing some bug fixing, to do Easy Hacks. So I hopefully had the chance to argue that from the left side, from LibreOffice to the right side to AI functionality, it's important to have it on open source, open data, and with the foundation TDF, which I mentioned as a foundation for good, will not go this way as OpenAI had done. You have the guarantee that your work is open source and will be good for all. Last but not least, I want to mention something else which I am really, really lobbying for. Keto and Kenzio, you know, I'm lobbying for labeling all content which is made by AI. So you can imagine then we are talking about an Office suite. And an Office suite is a perfect tool for integrating AI-made content and fooling people. So I am really for a rule that says, please label if something is, some content or reasoning or workflow is done by AI. To be open for that. And by the way, in this slide were no content AI produced. Yeah, with that, thank you very much. I hope I can give you an insight into where we stand in this Copilot challenge for LibreOffice, and I'm open for questions. Timo.
Hello, thank you. So the question is not about Copilot, of course, but it's not about Copilot.
Okay.
You know, in Sri Lanka there are lots of people who use laptops. I mean, we use it until they actually break down. I mean, so, but after some time you can't run the new software. So I go and try to put Linux on them, and then of course LibreOffice is the obvious choice for the Office suite. The issue is that some of the older people who are using, they are the ones who will use this, and they are used to that Microsoft, layout. So I've been trying to see, is there a way to, because it's open source, I'm sure you can kind of make the menu look like Microsoft Office.
This is really an interesting question. Do you know why? Younger people are complaining the other way around. Why are you not going with a UI which is more high sophisticated and so on?
Correct. So for us, that's not a problem. Yeah.
Yeah.
But for these people, sometimes, and so some of them have been introduced to some of these Chinese, reverse engineers to Office suites, which look just like Microsoft Office. But I'm sure, I mean, I was thinking somebody must have, you had that site, something hacks.
Yes, Easy Hacks, yeah.
Yeah. Is there something where they've done that? And so.
Yeah, we have a lot of tasks for doing exactly this. We have a slightly problem with, there is some UI copyright in Microsoft. For example, the icons, we can't use the same icons. They are on copyright. But certainly we can do a lot more to fulfill them. And even we can do it to configure it. Like if I'm old, I use this one. If I'm young, I want to use them. We already have done this. You can change the UI from these tapped UI to menu bar and vice versa. But you're right, we are open source. If there's someone who contributes to this, we can do this, yeah. Or see a business model in it. Timo?
Yeah, thank you for the presentation. My question is on so you talked about challenges in integrating generative AI in open source products, and so could Gen AI widen the gap between open source products and commercial applications because of the high computational power that is required for not only for training but even in inferencing? So can the open source community, from a economic point of financial and economic point of view, is there a viable business, or not a business model, some kind of a...
We have to convince customers or governments to fund such things. Out of the foundation, we have some funds, but out of the foundation we are not able to really to operate, for example, servers with AI functionality and so on. So we need contributions for that. Comes it from the government side, researcher side, or comes it from private companies? But the real answer is, that's the question. Sorry, I can't give you a better answer to that. But the interesting thing is, with open source, you are allowed to do this. You can do this. So you will have to find someone who is interested in it. And even you can do business with open source, as I'm doing with my company.
Thank you very much. I first want to have a small comment. So when we do hire, people for master thesis, PhD thesis, we think that people who have actually contributed to OpenAI source project, that's a very big plus. So I encourage you to,
Absolutely.
take
Every
up a note of
contribution,
that.
even to OpenAI, is positive. Definitely.
So the other thing I want to mention, it's really great that now this has nothing to do with the AI stuff. So now that you're getting successful in the sense that there are governments, using your software, there will also be other not so friendly governments and people who are trying to, sneak in bad code, evil code and stuff. So how do you handle this, right? I mean, how much extra effort does this put on you?
This is one task, for example, which is covered by the foundation. So there are around about 10 quality assurance people who are looking what is coming in, and they have to acknowledge if some functionality or code is going to the core, it's verified. So we have people to guarantee quality or the right functionality. There is an example you have in mind, what we have discovered a few months ago in open source, where over a long time there were infiltrated some functionality. Yeah. This is a challenge, and we address this with certified developers. We certify developer, and there are people dedicated for analyzing the quality.
Great, thanks.
Although LibreOffice has more powerful capabilities, just as you mentioned, more than Microsoft Office, I think the popularity has been gained by Microsoft Office. So what I wanted to know is, are there any things that you're planning in your roadmap to bring so that LibreOffice could gain more popularity among the users? Because even when I came to university only, I got to know about LibreOffice. So before that, I knew about Microsoft Office. But so are there any
That's why I'm standing here. Yeah, you're right, but believe me, it's a hard task. 95% of all is Microsoft Office. what we have is a share around about 4 to 5%. Yeah, we have to do more promoting. But guess what? I think this digital sovereignty aspect is bringing a lot of sensibility for that a monopolist can do what you want, even with your data, or can be forced, if he stays in USA, to give it to the government, or all these problems which come. Yeah, we would love to do more. We need more people who are doing this volunteering. Perhaps we can engage you here in Sri Lanka. We have one guy, very active guy, to promote LibreOffice more in open source events, in universities, because we need more young people, we need more AI stuff for it. Please help us, contribute. Thank you.
Professor, I have a question. So then you talk about that the Microsoft Office and so how the popular game for the LibreOffice. So in the LibreOffice has made some studies supporting proprietary formats like docx, SLS, like this often struggle with full compatibility, especially for the complex documents. So what new approaches could LibreOffice can take to improve the compatibility for like Microsoft Office documents?
So if I understood it right, you have asked about the compatibility problem. If you have a whole bunch of Microsoft Office documents, how to get it better working into LibreOffice, right? Okay, this is a typical migration problem. This is the most work we have to do when we migrate a customer from Microsoft Office to LibreOffice. Well, again, this is hard stuff. I tell you the following. As I said, open document format is a fully complete free documented ISO standard, document standard. So Microsoft is doing an open document exporting filter. So you can also export out of Microsoft Office an open document format. Now I tell you what's the challenge the other way around. If we have to import Microsoft Office documents, we have a lot to guess. The people, the developer who are writing these import and export filters have not a completely free standard where they a specification of this document format where they can look in and say, okay, if this is this kind of object, I have to do this with this, and they have to have example documents looking in Microsoft Office, what's happening with them, looking in LibreOffice, what's happening with them, and with this difference, developing import filters. So it would mostly help if Microsoft Office completely free this document format. They certainly will not do that. But this would help. But the challenge is to always run behind this Microsoft changes in document format, which are not completely free. They are free, partially, but there are parts in it which are not free, which we have always run behind and working on this compatibility. But to be honest, the last 2 years, there happened a lot. There happened really, really a lot because a lot of customers invested in these compatibility tasks, finding documents where something is not working, where the typical problems, your logo is not there, it's there, and so on, where they could be covered. What is still a big problem is logic, is macro. Okay, I think I've over time. So thank you so much also for your questions, and please help us.
Yeah, thank you, Professor Baker, for that enlightening session. We would like to kindly request you to remain on stage. And yes, we have prepared a small token of appreciation. And to hand over this token of appreciation, I kindly invite Dr. Chamat Keppetiagam. Thank you once again.
Thank you.
We are now entering the final session of the research presentations. It is my privilege to introduce our session chair, Dr. Kasun Karunanayaka, a senior lecturer at the University of Colombo School of Computing. Dr. Karunanayaka specializes in mixed reality and multisensory communication, holding a BSc from the University of Moratuwa and a PhD from the National University of Singapore. His distinguished career includes research roles at both the Imagineering Institute in Malaysia and the National University of Singapore. Dr. Karunanayaka's award-winning research featured at leading conferences and in high-impact journals has attracted international media coverage. He currently serves as an associate editor for the ICTer for Emerging Regions journal and has held several academic leadership positions, including chair for the ICTer 2020 conference. Ladies and gentlemen, please join me in welcoming Dr. Kasun Karunanayaka, chair for our final session for research presentations.
Thank you for a nice introduction and welcome to the final session. So during this session, we will be presenting 3 papers. So let me introduce the first presentation, which is going to be a very interesting topic, AI-based 3D simulation for drone flight dynamics. And authors are PMDS Amarasuriya and KD Sandaruwan. I will introduce the presenter's author. So it will be Mr. Shehan Amarasuriya. He holds a master's degree in computer science from the University of Colombo School of Computing and Bachelor of Science in Computer Science in University of Kelaniya. He currently serves as a probationary lecturer in the Department of Statistics and Computer Science, Faculty of Science, University of Kelaniya. As a university academic, Shehan counts many years of experience in teaching computing at undergraduate level in Sri Lanka. So let's welcome Mr. Shehan Amarasuriya for the presentation.
Good afternoon, all of you. Okay, my topic is AI-based 3D simulation for drone flight dynamic. So, first the introduction part. Unmanned aerial, we commonly known as a drone, have popular in the recent years. So, due to this reason, skills drone pilot are necessary for handling this operation. So, for this reason, simulator is a key component for handling these operations. For using this simulator, drone pilot can easily practice with their drone operations. For example, using this simulator, it provides the safety and also improve their abilities to get compatible with specific flying drones. So why we need the simulator? Because real-time experiments are costly and dangerous. And also, it provides the practice on risky maneuver safely. Also, if you can use this simulator, the models can serve as a prototype for unbuilt system and also variable that cannot be accessible for the real-world system. We can observe using the simulation. For example, if you want to analyze the some forces generated by the propeller system, we can use the simulator for identify the accurate value. So these are the research objectives. First one is analyze the current technique for use the simulating UAV movements. Next one is collecting the data for real flight scenario. Next one is developing the AI model for simulate the UAV movements accurately. So after building the model, next one is validate the model comparing the real world spice data. Okay. Let's move on to the literature review part. There are many researchers have done for the building the simulators. All of these method basically divide into two parts. One method is using the traditional technique that based on the mathematical and physics based model. Other thing is use the modern AI technology for building the simulators. As you can see the figure here, this is the first simulator developed in 1910. Okay, yes, this is the one type of method used based on the mathematical model. In this model, they are try to predict the speed on x-axis and pitch angle. They identify the relationship between speed on x-axis and pitch angle, and also speed on y-axis and roll angle. Also, speed on z-axis and yaw angle. But in this method, they are collecting the data only low speed rectangular path. So this is the other type of research conducted in 2020. In this method, they are try to predict the forces and torque generated by the propeller system. In this method also, they use the mathematical function to predict the value. Also, this is the another type of most popular simulation, AR sim simulator. In this method, for building the simulation environment, they use large number of parameters. For example, shapes of the drone, some environmental conditions like that. After considering different type of parameter, they are going to build the system. Also, this is the most famous simulators in the nowadays, DJI 5 simulator. In this method also, they use the physics-based simulation method. But in here also, there are a large number of parameters. They consider many parameters for building the simulator. And also, if you want to build a custom-made simulator, these simulators are not supportable. Also, all of these traditional simulators use the many parameters. They have more complex mathematical functions. So it is very difficult to build a custom-made simulator based on this traditional simulation. So other type of simulation model is using the AI technique for building the simulation environment. In this method, there are one research is here using the reinforcement learning for simulate the UAV movements. But in here, they are only one is focus only data collection part. In this data collection part, they collect the data from a small cube like 2-meter length from each side, a small area of the cube. So in our research, first we move to the methodology part. One step is the data collection. In this method, the data is collection from real flight scenario. Basically, it is used for DJI Mavic Mini drone for collect the real world data. It include basically 3 maneuvers, 8 maneuvering patterns, circular pattern and spiral maneuver. Totally, it contains 100,000 data points, cover nearing the 10 kilometers. So these are the large data set compared with other researches done in previously. Also, next step after collecting the data, next step is data pre-processing. If we collect the data from the drone, it has nearly 180 features. So out of these features, we need to select what are the important features for building the model. So there are 2 main features for building the model. One is input features and output parameters. For input parameter, it includes the parameters that is handled through the drone controller. For example, yaw, troll, pitch, roll, like that. That are the input parameter for the model. Then we need to predict the drone position and orientation based on this input parameter. These are the feature selection for the model. After getting the necessary features, next one is handle the missing values. Also, finally, remove the duplicate value. The reason for apply the generating the duplicates value in the drone is, if the drone is still in the same location without any movements, it will create large number of duplicates value. So it is need to remove the duplicates value also after finally normalize the data set and split the data set into training and testing. Okay. Before building the model, here you can see the correlation matrix. Here there is a negative relationship between pitch and elevator. It means there's a negative relationship pitch and elevator. It means when the drone is go forward, the nose of the drone is go down. That is mentioned, there's a negative relationship. Okay. Then after the data pre-processing, next one is the build in the model. Here I tried several type of machine learning models, multi-output regression models, SVM model, neural network model, and CNN model. Out of this model, CNN model gives the some satisfactory result, 78% as accuracy. For finding the accuracy of this model, I used the one technique, compare the real world flight data with predicted predicted real world data, compare the real world data with predicted values. That is the one type of quantitative validation technique I use here. Here you can see the sample testing result. The blue color shows the actual real path for the testing case. Here you can see the different type of models that give the predicted path. Compare with other manuals, the CNN model is try to predict the real world path some satisfactory way. Here the hyperparameter tuning for the CNN model. Okay. Here, if I consider the CNN model, in my method there are several output parameters. For example, I want to predict the drone position and orientation. Here, you can see the error variation of the yaw angle. It is high error variation compared with other output parameters. The reason for this one is, if you look at this distribution of the data set, compare with other parameters, the yaw value has not normally distributed. The reason for is that it is not normally distributed compared with others. Okay. If I build the simulation model, there are some limitations. For example, if we want to collect the data, it is need for expert drone pilot for collect the real manual pattern. And also, it is need to be considered there is no any wind in the environment, because if I collect the data in the some environment with wind condition, it will give the inaccurate result. Also, it is necessary to get the data from complex manual pattern for build the most accurate simulation environment. Also, it is need for large number of data set for build the effective model. Also, finally, drone is most transformed in the several industries. For example, it is used for transportation, disaster management, in agriculture. So due to this reason, most effective flight program are necessary for handle this operation. So if we have these simulators, we can easily handle this operation. So we can, rather than apply the traditional models, if we can apply the machine learning based technique, we can easily build the custom based drone simulator. Finally, in this method, I use only the quantitative validative method. It means compare the real world flight data with predicted predicted data values. So there's another validation method, qualitative validation method. In the future, I will try build the simulator environment and test the simulation environment with drone pilot. Also expand the data set with large maneuvering and combine this CNN model with MATLAB Unity environment. Okay. These are the reference. Thank you all of you.
Right. Thank you, Sharon. Thank you for the interesting presentation. Now the floor is open for the questions.
Hi. In terms of your features, you say there's 180 features?
Yeah.
But when you do the correlation matrix, the feature selection, how did you select the features in terms of?
Because I want to predict the drone movements. In the 180 features means it include battery information, gimbal information, camera information like that. These are not necessary for predicting the path of the drone. So I select the most important features for the building the model.
And how many features did you select out of?
Nearly I use.
Yeah, that's okay. Yeah, so a handful. But in terms of, you said you have taken off wind direction, wind and velocity.
Yeah.
Is there a possibility to add that, because in some of the simulations that is also useful?
Yeah, if I want to predict the wind, we have to use the wind sensors for predicting the wind and apply that values into the model.
Don't you think that is, I mean, there can't be, in the environment in terms of wind is so important, the velocity and direction of the wind, to be in the part of the simulation? At least in your future work I'm talking about.
Yeah, it is a part of the simulation.
Yeah. Any other questions from the audience? So when I have a question, like when you think about the real scenario, right, practical scenario, so what are the modifications you have to do?
For in the real scenario, I collect the data from specific tree patterns, 8 maneuvering pattern, spiral pattern and circular pattern. For considering this pattern it includes the many movements compared with other random patterns. Also in my data set it includes the random pattern also. So I select the real scenario for that tree patterns.
How many data points you consider?
Nearly 100,000 data points.
So what are the models you tested? I forget.
Multi-output regression model, support vector machine, neural network, CNN model.
So which one is CNN is?
CNN is give the best result.
What was the reason?
Because there is a more complex data point in the, it will generate more complex data set. So compare with other model, the CNN model is identify the best relationship between our input and output parameter. I also try the LSTM model, it will give the same result like that.
How many layers were there? How many layers were there?
Nearly 4 layers.
So you tested these different layers?
Yeah, I tested different layers, but I used the random grid search like that. If I increase the layers, it will give the low result.
Right. Yeah, I think we have consumed the allocated time for your presentation, and thank you, Shehan. Ladies and gentlemen, let's give a round of applause for Shehan.
Okay, thank you all of you.
So our next presenter, next paper title is Music Genre Classification with Multimodal Properties of Lyrics and Spectrograms. Authors are Janita Madhushan and Ruan Veerasinghe. So let me introduce the presenting author. Janita Madhushan is working as a technical lead at Cambio Software Engineering with 9 years of experience. He graduated from Faculty of Engineering, University of Peradeniya, Sri Lanka. He specialized in computer engineering and MSc in Big Data Analytics from Robert Jordan University, UK. Janita interested in artificial intelligence, machine learning, data engineering and big data programming. Janita, floor is yours.
Hello all. Our research topic is music genre classification with multiple spectral features and lyrics. And the authors are G.A.J.M. Senadira and A.R. Veerasinghe, and our affiliation is Informatics Institute of Technology, Sri Lanka. And these are the table of contents that I'm going to present you today. And the motivation is music genre classification is a widely discussed topic nowadays with the emergence of music streaming platforms. And there has been many research work done on the stream using unimodal models, multimodal models, and using different modalities such as lyrics, audio features, and spectrogram images. But including multiple spectrum features along with lyrics would improve the classification accuracy. And the research gap is to identify contribution of different modalities such as spectrograms and lyrics in music genre classification, and also to develop a deep learning model using multiple modalities. And our aim was to develop a multi-class classifier based on multimodal fusion mechanisms to utilize audio characteristics and also lyrics to provide an accurate classifier. And we formed these research questions throughout our study to find out which spectrogram or lyrics combinations provide high accuracies in music genre classification, and to determine what fusion methodology is efficient in music genre classification, and also to evaluate the proposed model with existing baseline models. And also in the literature review, we found that audio spectrum features based on Fourier transformation are used in music information retrieval. And recently, direct spectrum feature analysis has been changed into spectrogram image analysis in MIR. Deep learning models have been outperforming our traditional models in music information retrieval. MEL spectrograms, MFCC, and STFT spectrograms are good candidates to combine with lyrics for our study. And also just using 3 seconds of soundtracks are sufficient for generating spectrogram images that reduces a lot of computation power and storage as well. Transfer learning models such as ResNet 50 based on the ImageNet dataset, and also the transform-based encoder model BERT are effective in music information retrieval. And also we found that there are 3 different fusion methodologies are used in MIR. The feature concatenation, getting 2 multiple modalities and concatenate them at feature level to provide a single classifier. Decision weighting, getting multiple outcomes of different models and weight them and aggregate them into a single results, and hybrid fusion is doing both of them at once. And we got we used music for all data set for this study. Actually, we got this after signing a non-disclosure agreement with its authors, and it's about 50 gigs of size, and it had around 15,000 listening histories along with 100,000 songs and with their metadata. Audio tracks were in MP3 format, and they were 30 seconds of length, and lyrics were in the text format. And there were metadata in CSV files. They contained around artist, language, genre, and etc. This data set is a bit noisy. We found this in the experiments OS in the literature review as well. And we only selected English songs for this study. Actually, each song was given multiple genre classes in the data set, so we had to get the most tag the most prominent genre classes. So we used the cosine simulator for that to tag them into most 10 prominent genre classes. And you would see the table to the right hand side. There is the table that we were after we were tagging the data set. It is very much irregular data set, so we had to get selected a couple of genre categories from them to get some accuracy for our study. They were country, jazz, metal, and pop. And we did class balancing. We used both downsampling and upsampling mechanisms. We downsampled country, metal, and pop, whereas we upsampled the jazz class. As the upsampling mechanism, we used the time wrapping method to generate the spectrograms on different offsets, but we just duplicated the lyrics for study. And these are the features that spectrograms that we extracted from our study. First one is MFCC, MEL spectrogram, second one is MFCC, and third one is SCFT for each genre class. And they were 24 to 24 RGB in size. And to the right hand side, you see a sample lyric file in the dataset. And we developed unimodels based on ResNet 50 and BERT-based models, adding some classification heads over them. And we performed weighted average predictions to find out the contribution of each features. And these are the two architectures that we used in our study. The first one, the models were given music as spectrogram images and lyrics in the text format. We used the ResNet 50 and BERT-based models with their initial weights frozen and added a couple of layers after that, and we trained them. You would see the final layer is dense 4 because we had only 4 classes. And we trained 4 unimodels using lyrics, MEL spectrograms, MFCC and SCFT. First one is for lyrics and the other 3 is for training spectrogram images, and we extracted F1, F3, F2, F3 features for the feature concatenation. And this is the function that we use for getting weighted average predictions to evaluate the modalities. Each outcome of unimodals were multiplied by constants, where alpha, beta, gamma, and delta, whereas the summation of the constants should be equal to 1. And we did, to answer our first research question, to find out the right modalities, we did a couple of experiments with using linear sensible combinations to evaluate the F1 scores with using the weighted fusion, weighted average outcomes. You would see in the 6th experiment, we got the highest F1 accuracy of 0.71 only for use in lyrics, MFCC and MEL spec combination without the STFT, and they were contributed equally. And with that outcome, we dropped down the STFT from our research work, and we got MSpec, MFCC, and lyrics trained unimodels from that, and we frozen their initial weights and removed their target layers and concatenated them and added 2 layers. After that, then we trained it. And to answer our second research question, we performed weighted average, feature concatenation, and hybrid fusion predictions. You would see in the first table, we got the highest accuracy measures for the hybrid fusion method. And also in the second table, you would see the F1 scores for each genre class. In most of the cases, we got the highest accuracy for the hybrid fusion method. And these are the accuracy measures for each genre class. And you would see the highest precision was recorded in the metal class and then in the pop class. And this is the confusion matrix that we obtained for the hybrid fusion method, and we noted the highest confusion between country and jazz class because jazz is made up of country class. And to answer our third research question, we selected 3 baseline models. First one is to evaluate with our proposed model. First one is BERT CNN model, which was based on the hybrid fusion. It utilized MSpec and lyrics. Second one is triple CNN model. It is a feature concatenation model. Was using MSpec, MFCC, and STFT spectrograms. The third one is a BERT CNN model. It was using a feature concatenation. It was a feature concatenation model. Utilized lyrics and MSpec. And you see in the first table, our proposed model performed better, and also in the second table, you would see the outcomes for each genre class. In almost all the cases, our proposed model performed better. And in the conclusion, we could say our proposed method is at least 5% accurate than the baseline models. And also MSPEC, MFCC lyric combination provides the highest accuracy for the music genre classification. And including more machine-friendly spectrograms such as STFT fails to improve the accuracy of the classifier because it is unable to capture the harmonic features of the songs, and the provided the proposed model's generalizability, robustness, and versatility shows the model's ability to capture unique features of the each genre class, and F1 scores were ranging from 0.64 to 0.85, whereas other baseline models shows higher variances than that. And jazz was initially included in classes like country, then with focusing on relaxation, variation, and improvisation, country jazz was made up. So that's why we noted the highest confusion on it. And balance F1 scores, precision, and recall suggest neither false positive or false negative has been adversely affected the results. And this study has limitations. We did this study for only 4 classes, but this can be extended at least up to 10 prominent genre classes. In order to do that, we have to have a good data set because music for data set is highly imbalanced and a bit noisy. And as a feature enhancement, we could include emotions to this model using multitask learning. And in this study, as upsampling mechanism, we just duplicated the lyrics, but we could use generative AI technologies to generate slightly different lyrics for our study, like using methods like paraphrasing and that. And when we were finding the combination of these modalities, we used a narrow set of linear combinations, but instead of that, we could use a wide range of combinations to get the most suitable variable values for the predictions. And these are the references that we used in our study. And now it's time for the Q&A.
Thank you, Janita, for interesting presentation. Any questions from the audience?
So, to find out weights, you selected randomly some 1.33 like alpha, beta, and gamma. How you selected? How you selected the best one?
Actually,
in the table, I can see about 10 combinations.
Yeah.
And then based on that, you drop one.
Yeah. Yeah. Because it is a bit costly in order to do a wide range of variables. In order to do that, we have to have some kind of high computation power. So also we have mentioned that in the feature enhancements. Did I answer your question? Okay. Yes, we used a narrow set of linear combinations for do that because we used have to have a good computation power for that. So in the feature enhancement, we have mentioned that in the to use a wide range of linear combinations.
Any other questions?
Hello, yes. Thank you for the presentation. So my question to you is, during your study, did you all consider any other LLMs for this particular task? Because compared to BERT, the other LLMs have billions of parameters trained on them, so did you all consider them?
No, actually we only selected BERT because in the literature we found out that BERT was widely used and got many good accuracies in music information retrieval in other and also in other works in music information retrieval, so that we only use the BERT. We didn't use any other LLMs other than that.
Thank you. So just a clarification. The generative LLM models are generally not good for classification tasks. I think this is a common mistake. Right? They are being used now for classification tasks, but they're not suitable. So you need to use a discriminative model, and that's why BERT was used. I guess the alternatives were Roberta and that family, the encoding transformers.
We have time for one question, if there is anyone. No questions? Okay. Thank you very much, Janita. Let's give a round of applause for Janita. Right. So we are coming to the last presentation of the session. Paper ID 20, modified discrete wavelet transformation to compress DICOM medical images with run length encoding. So it will be, the authors of the paper is T.M. Imbuldeniya and R.G.N. Meegama. Presenting author is T.M. Imbuldeniya. So Tisura Imbuldeniya is a graduate of the Faculty of Applied Sciences, University of Sri Jayawardhanapura, holding a BSc Honors degree in computer science. His research interest focused on image processing and bioinformatics, where he aims to explore innovative computational methods to advance both theoretical understanding and practical applications. His research titled Modification Discrete Wavelet Transformation to Compress DICOM Medical Images with Run Length Encoding focuses on enhancing medical image compression using innovative algorithmic techniques. So, Tisura, over to you.
Okay, good afternoon, everyone. So I am Tisura Imbuldeniya from University of Sri Jayawardhanapura. So with this presentation, I'll be presenting the research outcomes of my latest study, which is devising modifications to the already existing discrete wavelet transformation method in compressing DICOM images. So this was done under the supervision of Senior Professor R.G.N. Meegama. Okay, so this is the overview of this presentation. So let's start with a little bit of introduction. So DICOM standard is the international standard for medical imaging and related information. And these images tend to take a lot of storage space, especially in uncompressed format. So compressing these images can be beneficial for, there are special scenarios where storing them for long periods of time, or even in telemedicine use cases. And image compression can be done by exploiting some of the redundancies that are present within the image. So mainly there are three types of redundancies: coding, interpixel, and psychovisual redundancies. But exploiting these redundancies can be efficiently done by transforming the image from spatial domain to the frequency domain. And one such technique of doing that is discrete wavelet transformation. Here what happens is the image is treated as a 2D signal, and we use 2D wavelet analysis to decompose the image. So like I have mentioned in the previous slide, these DICOM images tend to take a lot of storage space, especially in the uncompressed format. So compressing them can be beneficial for storing them for long periods of time, maybe for research purposes, and even for in edge cases like telemedicine, especially for like underprivileged areas, it would take a lot of time to communicate if the images are in uncompressed format, and takes a lot of it will take a lot of bandwidth. So because of that, in such scenarios, compressing these images, especially while maintaining the visual quality as well as the clinical information, can be beneficial. So the main objective of this study is to devise modifications to the already existing method of discrete wavelet transformation in compressing medical DICOM images. And this is the breakdown of this of my primary objective. So I will take a little bit of look into the recent studies that has been done in this area. So the first one, I have included this because it includes some of the comparisons done between the two transformation techniques, especially the discrete cosine transformation and the discrete wavelet transformation. And what they have concluded is that the discrete wavelet transformation had performed better in terms of quality wise, but in terms of performance wise, the DCT was better. And DCT is already used in formats like JPEG format. And even in the second research, they have already also done another comparison. So even their outcomes also align with the previous one. So indicating that DWT had performed better in terms of quality, preserving the quality. So the next one, they have proposed a method of compressing these medical DICOM images based on DWT and Huffman encoding. Here they have used 3 wavelets. Actually, they had mixed results from these wavelets, but overall their method had performed well, and they have concluded that they were able to get favorable outcomes. And one other notable thing is that they had used the entropy of the image in order to determine the decomposition level. And once decomposed, they have applied thresholding, as well as then they have used Huffman encoding to further reduce the size of the data that is used to represent the image. And the next one, once again, there's another novel method that they have proposed. Here they have used vector quantization in between discrete wavelet transformation and encoding phases. So because of that, they were also able to achieve some favorable outcomes. So let's go through my research methodology and the modifications that I am planning to devise here. So this is the overview of the research methodology, and in the first phase, the preparation phase, what I do is, what we did was, we separated the image data, the spatial data, from the metadata, because the DICOM image consists of multiple data, as you can see in this diagram. So we separated the spatial data, which includes the pixel values, and after that, what we did was, we applied transformation, discrete wavelet transformation, to transform the image from spatial domain to the frequency domain. And here what this transformation yields is the 4 subbands. So we get the approximation for the original image, which is resulted from the LL. Actually, it is resulted from passing the image from 2 low pass filters. These pass filters actually filter out the frequency components from the image. So basically, for the low pass filters, it will pass the low frequency components, and it will reject the high frequency components. And by doing so, we'll end up with 4 subbands. And this can be mathematically represented in this manner by using the product of 1D scaling function and the corresponding wavelet. So this is what actually happens. So in practical situations, what happens is, we pass this image through a filter bank. So this filter bank is compromises. It consists of it has these high pass and low pass filters, as you can see. So these pass filters will filter out the frequency components, and it will provide us the 4 subbands as shown in the second figure. And this is an image where I decomposed a certain CT image, and based on the coefficients that it produced in the 4 subbands, I have reconstructed back. So here what you can see is the approximation coefficients. It provides the, it actually gives you the cos of that image, and the other 3 actually highlights the details, horizontal details, vertical details, and diagonal details. So once the coefficients are generated, the next phase is to threshold them. So this thresholding, what we have done is we did hard thresholding. What happens here is whatever the value that are below the threshold level would be set to 0, and the remaining ones, the values that are above the threshold level, would be taken to the next phase. And here's a comparison between the coefficients before thresholding and after thresholding, and we defined a certain parameter, and based on that we defined how much of information to retain from the coefficients, and based on that we decide the threshold level. So basically we decide the percentage, or rather the fraction of information that to retain, and based on that we get the threshold level, and from that threshold level we threshold the coefficients. So the next phase is quantization. Once the coefficients are thresholded, we need to quantize them, and here we have used uniform scalar quantization. So what happens is an infinite set of values, possible values are discretized to a certain step sizes, and since we are using uniform scalar quantization, the step size is uniform, meaning it's a fixed value. So here you can see the comparison, or rather the distribution of the coefficients, wavelet coefficients before and after quantization, and here the step size was shown here, is taken as 20. So the next phase is entropy encoding, and after quantization what we did was we entropy encoded based on few methods, and first one we applied run length encoding, and here it was identified that the approximation coefficients actually yielded some undesirable results when applying run length encoding, and because of that we excluded that coefficient matrix from the process, and we concatenate the remaining 3 matrices, and when we are applying the run length encoding, we traverse the concatenated matrix under three ways. First one is a linear traversal, then we did diagonal traversal, and finally we did spiral traversal to investigate the effectiveness. Once RLE was applied, then we used the deflate algorithm, which comprised of LZ77 and Huffman encoding, and we further entropy encoded the already coded data using RLE. So this yield the compressed image, and thereafter we can do the inverse of that, or the reverse process, in order to get the reconstructed image. So the first phase of getting the reconstructed image is to get the entropy decoded. So here we applied the inverse of run length encoding, and also we need to apply the inverse of deflate algorithm in order to get the decoded values. And once we get the decoded values, we can apply the dequantization. And since we have used uniform scalar quantization, we can basically multiply the data points using the step size. And once we dequantize the data points, we can now we'll end up with the coefficients actually. So we can feed that to the inverse discrete wavelet transformation function, and we can reconstruct the image based on that. And also we can do a DICOM write back by combining the reconstructed image or the image data, spatial data, and combining the metadata that will be saved separately along with the coefficients when we are actually storing them. So for evaluating the research, the study, we used certain metrics. The first one is mean square error and the roots mean square error. And we used PSNR or peak signal to noise ratio. The previous one, the lower is the better. And when it comes to peak signal to noise ratio, higher is the better, and it can be defined for an image, especially for a 16-bit image in this manner. And the next one is mean absolute difference. It is quite similar to the mean square error as well, and once again lower is better. And the final one for evaluating the quality is the structural similarity index, SSIM. Here it will compare two images and it will evaluate the structural similarity between two of them, and it's an index. So any value that is closer to 1, it's a good result. And finally, we have used compression ratio to basically evaluate the effectiveness of the algorithm. So we obtained the results based on two criteria, and the first one is by varying the threshold rate. Here what we did was we varied the value, the threshold level on a certain metric. We call it as the threshold rate. So basically what it does is we define a certain fraction, like say for an example 0.2 means we are retaining like 20% of the information. So based on that we define the threshold level, and for that threshold level what we do is we calculate all the matrix values such as MSE, RMSE and PSNR, such values, and for all the 16 images we took 16 DICOM images from open DICOM repository, and for all the 16 images we averaged that value for that threshold level and threshold rate, and we plot those values to find the effectiveness of the modified variance against the general discrete wavelet transformation with Huffman encoding. And the second criteria was we define a certain target MSE, and for that target MSE all the algorithms, the modified ones as well as the general version, the algorithms needs to try to provide the best compression ratio. And since we are fixing the MSE and we are setting a target value for the MSE, that means the quality of the reconstruction would be almost similar. So we can directly compare the compression ratio in the second case. So here are the obtained results. So the quality metrics, the RMSE, PSNR, you can see that there is not much of a difference that has been occurred with the modified variance against the general version of DWT. So that means not much of quality degradation has occurred, and you can see once again the quality matrix, the mean AD and SSIM. But when you look at the compression ratio graph, you can see some significant improvement in the modified variance when compared to the general version of DWT. And this result is further, it is further, we can confirm that for further level by looking at these two charts, because when we set the target MSE to certain values, for an example 100 and 225, the compression ratio achieved by each algorithm is shown here. So the general version of DWT with Huffman encoding and the modified variants are shown here. So you can see some significant improvement when in the compression ratio, especially when we are setting the target value for a specific value. So we can assume, or rather we can certify that the quality of that image is at a similar level. So these are some these are some reconstructions of the original image. Actually here the images are converted to JPEG. So just to present here. So as a conclusion, the modifications can be summarized as follows. We have used uniform scalar quantization, but here actually we did some adaptive uniform scalar quantization, especially this quantization step size is uniquely calculated for each and every image, and after that we applied run length encoding and deflect algorithm for entropy encoding, and we used the multiple traversal mechanisms, linear, spiral and diagonal for traversing when applying run length encoding, and also we only applied RLE based on the entropy of the coefficients. So apart from that, there are some limitations in this study. We only did this research for 16-bit images. So there are other types, other variants like 8-bit DICOM images as well. So this study does not consider that part. Also, it has not been done for RGB DICOM images. So, and there are some other quantization techniques as well. So this can be extended for such as well. So here are the references, and thank you. So I'm open for any questions that you have.
Thank you, Tisura, for interesting presentation. Floor is open for questions. Any questions? I have a question for you. Generally, like in medical imaging compression, we are using lossless compression techniques, and run length coding, for example, like lossless compression, right? DWT can be implemented on both ways, lossless or lossy compression. So which way you went?
Sorry.
Is your proposed algorithm lossless or lossy
here
compression?
Actually it is lossy because we are thresholding and we are discarding some of the coefficients. But if you look at the metrics, the quality, the SSIM, it is actually closer to 1, meaning that there is not much of a structural difference between the original and the reconstructed image. And also, even though the MSE is a little bit high, it's mainly because of the bit depth. Since we are dealing with 16-bit images, the MSE is a little bit high, but apart from that, the actual quality of the image is really good, and because of that, if we can actually go for a lossless one, but I think by actually adding some lossy component, we can improve the compression ratio in a significant manner because of the thresholding as well as the quantization.
Right, thank you. Any other questions? So if you go for more than 16-bit, like 32-bit, 64-bit, then there might be more limitations on the algorithm, right? Probably you will get better compression, but
actually,
you will lose more
for
data.
DICOM images, I am not sure whether we have that much bit depth available. Yes, there are 8-bit DICOM images, but generally most of them are 16-bit.
16-bit.
From like CT scans and MRI scans, they produce 16-bit DICOM images.
Right.
So that's why the main focus here was 16-bit images. But these are actually grayscale images. They are not RGB 3-channel images. But for an example, ultrasound scans, now they produce kind of RGB images, even though they are not actually color images or something like that, but they have 3 channels. So 3 values are there for RGB. So that is not considered in this research. So only grayscale images are considered. So only one value for single pixel.
Right. Thank you, Tisura. So our time is up, I think. Ladies and gentlemen, so let's give a round of applause for Tisura. And that will be the end of the final paper session. Thank you.
Thank you to all in this session. Yet again, I have the pleasure of inviting Dr. Kasun Karunanayaka, our session chair, to present the certificates to the presenters. Would the following researchers please come forward to receive their certificates? Shehan Amarasuriya. Janita Senadira. Tisura Ambuldenia.
Thank you, sir. It is now time to recognize the outstanding contributions of our presenters and award winners. We invite all attendees to join us in celebrating the hard work and dedication of our researchers and innovators. Our first award of the day is the prestigious Best Paper Award of the 24th ICTer International Conference. This award is a celebration of excellence in research, highlighting the paper that has demonstrated exceptional quality, innovation, and impact. To present this award, I would like to invite Mr. Aruna Lorenzo Haver, Senior Lecturer of the Department of Computer Science in the Faculty of Science of the University of Ruhuna. The Best Paper Award goes to AI-based 3D simulations for drone flight dynamics by PMDS Amarasuriya and KD Sandharuvan. Ladies and gentlemen, it is my privilege to invite on stage the presenters of this paper, PMDS Amarasuriya.
Now, let's move on to the awards for the I'm a Researcher competition. This event honors exceptional talent and inspiration in research and academia, celebrating young researchers who are advancing knowledge and driving innovation. Please join me in applauding our outstanding awardees. To present the I Am a Researcher Awards, I'd like to invite Dialogue Finance, our silver sponsor. Awards will be given away by Mr. Raveen Dimel, Assistant Vice President, FinTech Consumer Business, Dialogue Asiata PLC. First, we have the Most Popular Researcher Award, which comes with a prize of 50,000 rupees. This award recognizes not only excellence in research, but also a unique ability to connect, engage, and inspire both academic and professional communities. The Most Popular Researcher Award goes to A.M.M. Father of University of Colombo, Faculty of Science, IT and Management. Next, the Most Contributing Researcher Award, with a prize of 75,000 rupees, honors an individual who has made significant contributions to their field and community, creating a positive impact beyond the academic world. This award goes to WMK GVB Vijaykorn of University of Ruhuna, Faculty of Engineering. Ladies and gentlemen, finally we have the Young Outstanding Researcher Award, carrying a prize of 100,000 rupees. This award celebrates remarkable achievements early in one's career and a potential to break new grounds in research. We can't wait to see where the journey takes them. The Young Outstanding Researcher Award goes to S.R. Kure of University of Colombo School of Computing. A huge congratulations to all our winners for their inspiring accomplishments. Thank you for your dedication and hard work.
As we approach the conclusion of ICTer 2024, it is with gratitude that we acknowledge the contributions that have made this conference a success. To convey our appreciation, we are honored to invite one of our event co-chairs to the stage. Please join us in welcoming Dr. Lasanti Da Silva to deliver the vote of thanks.
Good evening, honorable guests, distinguished speakers, sponsors, valued attendees, and committee members. As ICTer 2024 draws to a close, it is both a privilege and an honor as co-chairs to express our deepest gratitude to everyone who contributed to making this event such an outstanding success. First and foremost, we extend our heartfelt thanks to our sponsors whose exceptional support has been vital in bringing this version to life. Gold sponsor, Cambio Software Engineering. Silver sponsor, Ginny from Dialogue Finance. Bronze sponsor, WSO2. Keynote sponsor, Exam Genius. Partner of Keynote Honor, a taste of Ceylon provided by English Tea Shop. Stationery sponsor, Unideal. Enterprise Connectivity Partner, Dialogue Enterprise. Business Promotional Partner, People's Bank. And Mobility Partner, PICME. Thank you for your generous contributions that made ICTer 2024 possible. We also offer our sincere appreciation to our esteemed keynote speakers who travel from all around the world to share their expertise. Your insights have been invaluable, and we are confident that they have inspired all attendees, adding immense value to the conference. We also thank everyone who facilitated connections with the keynote speakers and offered support in joining ICTer 2024. We congratulate all the authors on their achievements, and we are grateful for the support provided by the Best Paper Selection Committee for their dedication commitment throughout the conference. I would also like to extend my heartfelt thanks to the students who participated in the I Am the Researcher event. Your curiosity and dedication were truly inspiring. Your active engagement in the sessions not only contributed to the success of the event, but also brought a fresh perspective that added tremendous value. Thank you for your motivation, for asking insightful questions, and for making this event a memorable experience for everyone involved. Our deepest thanks goes to the advisory committee, especially Dr. Ajahn Tatukorala, Director of UCSC, and Professor Kasun Disoisa, Deputy Director of UCSC, for your guidance and exceptional support throughout this journey. An event of this magnitude truly takes team effort, and I would like to acknowledge the remarkable contributions of all the committees and volunteers who worked tirelessly behind the scenes to ensure the success of ICTer 2024. The Technical Program Committee, under the expert leadership of Dr. Asanka Sayakara and Buddhika Disanayaka, ensured the highest quality and rigor in the technical content. The Keynote Committee, led by Ms. Sanduni Tirimavitarana, coordinated with our keynote speakers, managing logistics and hospitality to ensure a seamless experience. The University Liaison Committee, led by Mr. Isuru Maduranga, showed exceptional dedication in organizing the I Am the Researcher competition. The Workshop Committee, chaired by Mr. Tarindu Vijayasinghe, organized thought-provoking workshops that provided invaluable insights to our attendees. I would also like to acknowledge IIT for sponsoring shared task competition on large language models. Thank you. The registration committee, managed by Mr. Viraj Velgama, ensured a smooth and efficient registration process for all. The logistic committee, led by Ms. Nilmani Ratnayaka, coordinated all the logistical arrangements, contributing to a seamless experience. The finance tech committee, led by Mr. Kolita, effectively managed the financial operations of the conference. The Media and Publicity Committee, led by Dr. Samantha Matararachi, ensured widespread coverage of ICTer 2024 with special acknowledgement to ADMTC and Pahasara Media team for excellent publicity and media coverage. The session chairing committee, led by Ms. Lakshika Nanayakara, coordinated an exceptional lineup of speakers. The comparing team, led by Dr. Shiromi Arunatilaka, Ms. Sasanjali, and Mr. Kenneth Tilakaratna, guided us professionally through each session. Our exceptional compeers, thank you for your dedication and for adding the extra touch of brilliance to this event. The technical team, led by Mr. Kenneth Tilakaratna, for their exceptional work in ensuring the flawless execution of all technical aspects of the event. I would also like to thank the main organizing committee, Dr. Chamat, Dr. Shiromi, Mr. Kenneth, Dr. Andil, Dr. Sandaruan, Mr. Tarindu, and Dr. Manju, for fostering a collaborative atmosphere that made decision-making effective. Your dedication, long hours, and unwearying commitment have been the driving force behind this conference's success. A special mention to Ms. Madhumali, our Secretariat, for her tireless efforts, and Ms. Nisansala for securing some sponsorships. We are also immensely grateful to the conference administrative team, Ms. Deepani and Mr. Gunaratna, the Director's Office, especially Ms. Renuka and Mr. Akila. We are grateful for the staff of Marino Beach Hotel, especially Mr. Pidushan and Mr. Danu, for helping us to make it a very comfortable experience for you all. To all the delegates, authors, participants, and attendees, thank you for your active participation and engagement. Your presence has been integral to the success of ICTer 2024. We hope you leave with new knowledge, connections, and ideas that will inspire future innovations in your fields. Last but not least, I would like to express my special gratitude to Mr. Kenneth Tilakaratna for his exceptional work in managing all the groundwork and coordinating the event seamlessly. His dedication and organizational skills have been key in making ICTer 2024 a truly outstanding success. In closing, ICTer 2024 stands as a testament to the power of collaboration. It is through the combined efforts, commitment, and passion of every team member that we have achieved something truly remarkable. Thank you all, and we look forward to welcoming you to future ICTer conferences. Safe travels and best wishes until we meet again at ICTer 2025. Thank you.
Thank you, Dr. Lasanti. Prize winners of I Am Researcher, you are kindly requested to check your phones as the prize money has now been transferred to your accounts via the Dialog Genie application. As we conclude ICTer 2024, we want to express our heartfelt gratitude to each and every one of you for your presence and contributions. While every ending marks a new beginning, we leave here with renewed inspiration and a commitment to advance our fields. Let's carry the spirit of collaboration and innovation beyond this conference, fueling our journeys of discovery and progress. Right before we say our final goodbyes, we invite you to enjoy some evening tea. Thank you for becoming part of this extraordinary gathering. Signing off, I am Rosara Dayaratna.
And I am Abdullah Jasmine.
This is the ICTer International Conference 2024.
with more talents, with more insights. We will be back again in ICTer 2025.